Yeah. So we'll start now with the softer skill. That is, so far we have seen most of the scientific part, about biorefinery, what is bioeconomy, circular blue bioeconomy, and then processing technologies, ingredients and products. Now we are towards the end of it, and that is all to do with to understand what is research, what is innovation, what is business model, how do you engage with different stakeholders. So main focus will be to differentiate what is research, innovation, and how do we, why do we do research, and how do we engage or benefit to the community. Yeah. So what is the difference between research, innovation versus invention? Invention is to find a new thing. You find something new, that's an invention. But innovation is slightly different. So once you have a knowledge and you use that knowledge to convert into revenue, that should be innovation. That means scientific knowledge is there, yeah, and generating a knowledge can be a invention of creating a new space of knowledge, and when you convert that one into revenue, that will be known as innovation. Whereas revenue is used to create a knowledge, that will be research. Yeah. Institutions are there, they get money, and you pay fee to generate, to get the knowledge. Yeah. So you use money to generate knowledge. Yeah. In what form? How knowledge is generated? That is one way of seeing it as a research. Yeah. You need money to carry out the research so that you create a new scientific knowledge. When the same knowledge is used to create revenue, that will be considered as innovation. Is that clear? So you need a money to do the research project. Research project is there, people are employed on it, people they do PhD and they get stipend, salary. So what is their purpose? To create a knowledge. Yeah. Once you create a knowledge, you develop a technology, you develop a process, and that particular process is again used to generate income. That's the purpose of it. Yeah. So conversion ratio cannot be 100%. Yeah. So revenue to knowledge is X percentage, but knowledge to revenue can be quadruple, yeah, or 100 times of X. Yeah. So that is the way we have to see research and innovation, and difference between invention and innovation. So invention, finding something new, finding how finding telephonic communication was invention, and all those things what is coming on now is all innovations. Yeah. The chip, so including that system. So that must be very, very clear. What is research? Using revenue to create a knowledge in form of research, project, purchasing a book, generating the knowledge. So that is all one side. And when you use the very same knowledge to create a revenue, that means you got the knowledge, you made a system, and you start a new business, that is startup. Yeah. That will be innovation. Is it clear? So that's pretty much straightforward. So what should be the research and what should be the innovation activity? What does it mean? What are different types of research? Research are normally classified into 3 different categories. Yeah. Basic, applied and commercial. Majority of you in food science is in applied research. Yeah. Basic research will be how butterfly flies, how plant grows, yeah, what happens to the plant, how plant converts CO2 and water into glucose. That is all basic research. Yeah. Understanding, that is fundamental aspect. And when you apply that particular knowledge, that becomes applied research. And if that particular applied research is done to develop a big processes, that is advancing the technology readiness level, that becomes commercial research. Yeah. Investigating the shelf life of a biscuit company's product, yeah, that is exactly a commercial shape of research. Yeah. Within that one is exploratory. Yeah. What else? Experimental. That means you carry out experiment, and other one can be investigation. Yeah. So, can you give the mic? Yeah, here, first one row. Sorry.
Sir, any other research just like qualitative, quantitative, and fundamental or exploratory you were already mentioned.
Which exto?
Sir, you were already mentioned exploratory.
Fundamental research.
Sir, descriptive research.
Qualitative, quantitative,
descriptive.
Yeah, descriptive, and all these type of stuff. For example, carrying out the survey.
Yes.
Other day when you received a questionnaire survey, that was basically qualitative. Yeah, quantification. These are again further classification of the research activities. So here focus was mainly on the research what are related to innovation activities. So if you will see what are your motivates for answering this way, right? That means I do this research for publication. I do this research to solve this problem. Yeah. So what is your exact motivation to answer that, whether you are doing basic research, applied research, or a commercial research. Yeah. And again, what are the advantages of applied and commercial research beyond fulfilling the funding requirement? Suppose you get a funding, yeah, you as a PI or somebody is running a project to develop your project, for example, developing a treatment strategy for wastewater by X, Y, and Z technology. Yeah, will it be applied research or will it be a commercial research, or will it be a basic research? So it will be basically applied research. Yeah, wastewater is there, and then you are trying to use technology, for example, microalgae, which can quench some of those inorganic nutrient into organic form. So you are trying to use that one, so that becomes applied research. When you make a process, that means A species, B, sorry, I am very bad in using this one, A species, B technology, C end product. Yeah, you develop the process. Yeah, taking this much amount of water, this should be the flow rate, this is the species to be grown for this many days, and then this is the technology to use, and this is the product what you will obtain. Yeah, this all becomes process, and if some company is interested in that one, or you start your own business, that becomes commercial. Yeah, that means scaling that one up at a commercial scale becomes commercial research, right? Now, what is the advantages or disadvantages of different types of research? So the moment you go into further different type of categories, fundamental research, qualitative research, quantitative, descriptive analysis, and all those things are there. Yeah, some research is carried out only to get the information, so that you can create a policy, like surveys. Yeah. So all those information, you fill a lot of surveys every time it comes on email. Like other day you got it with the QR code. Yeah, that was mainly to see what is your perception and what you think what is required to be done. Yeah, I'll run through those answers maybe today at some point, or maybe in evening today. Yeah, so that was quite interesting to see whatever we covered. Pretty much it is within that particular line. Some places some differences were there. So that was only because there was no all of the above choices were given. Yeah. Now in that case, so what is the advantage of basic research?
Sir, it is the pure research. It on basic on the mathematical. So this is the basic, and when we applied that particular, just like microalgae, we can grow in wastewater. When we applied and do the practical, it's called the applied research.
Okay. So basically, basic research is again, well, mathematical is one way of putting it. Basic is to know how things happen. Yeah.
What is happening and how it is happened.
So I'll give a common example of the gravity. Yeah. When we develop equation in your, when you said about mathematics, we put a gravity equation. Yeah. That becomes a basic research. Yeah. When you apply the gravitational force to transfer product from A to B, that becomes applied research. Yeah, and then you make an engine, that is, this is the principle, you make an engine or rocket engine, and then it is used to test different ways, that becomes commercial. Yeah, so that's the way you have to be very sure what we are doing. So in majority of the cases, commercial research is for monetary gains. Yeah, that is generating revenue. Yeah, applied innovation side of it. Yeah, right, and basic as a research. Yeah, innovative research, basic research, fundamental research, right. So this is for creating the knowledge. Yeah, innovation and revenue generation, right. So that's the way link between research and innovation. So what way we should carry out the research? What should be the priority? Like, for whom we should do the research? Just to be employed? Why should we do research? So before that, if you go in ecosystem model, right, this is money, idea, that is technology, what is called technology readiness level, concept developed. Yeah, oh, this works like this, why don't we make this? That becomes concept. Then you prove that concept. Yeah, I'll take your example of your osmotic dehydration. Yeah, it is known that osmotic dehydration draws out the water. Yeah, you use osmotic dehydration for your cheese or paneer. Yeah, so you developed a concept. Yeah, and then you try to prove it that it is better. Yeah, and then you validate it. Then you validate in relevant environment, that is at commercial setting, because what works in a lab may not work outside. Yeah, then you demonstrate in relevant environment, then operational environment, that means at real factory setting, and then you configure the system what all is required, because what is done in lab in small centrifuge cannot be done at large scale centrifugation. There you have to have a different system, and then you launch it. Yeah, so that is the sequence of any idea or any technology. So majority of the idea, they start from here, they end up here. Yeah, or you can take this as a most comfortable zone. Yeah, advancing any TRL from here to here, it takes ages to get it done. That means setting up machine at nuts and bolts at this point. Yeah, so if you are using an ultrasonic system for extraction, we think next day it will be having a commercial one, right. So all those things at this point takes lot of time and money and investment. Yeah, so that's why if you would have been part of different organization, you would have seen that some people, they got industry project. Oh, I got 10 million euros industry project. What is to be done? How do we make paneer? Yeah, oh, it's very simple. It is simple. If you do it in a lab, the moment you scale it up, the number of different challenges are there, and to operate it at particular environment. Now, this is the story with public funded research. Yeah, majority of the public funded, whether it's a university, institutions or research organizations, all those type of research, PhDs project, postdoctoral project, all those fellowships, these all are pre-competitive research, that is some with the fundamental research max to max at this level. Yeah, applied, majority of the research what I heard from some of you doing is falling here. Yeah, nuclear physics, establishing the equation of nuclear fission. There is another GIAN course going on, you would have seen the board about stars and all. So those all are coming in this particular space. Yeah, second part is industry funding. Industry is not much interested in basic research. Yeah, their main focus is what is the technology you have, what is the process you have, how I can make money out of it. That's their problem. Yeah, or that's what they want to establish. Yeah, you found a new ingredient which is having a better shelf life, or you got a new protein compared to dairy protein, and then they want to get that particular process developed to get competitive R&D. Yeah, so every multinational, every industry is having some bit of research department, yeah. And if you'll see, their research department is not as broad as what you guys do, yeah, or institutions they do. Because suppose it's a dairy company making cheese, then they only focus on dairy. They won't go and working on oats, another one, yeah. So that's, and where most of the institution they fall, or where my own organization falls in between. Okay. What does it mean? So there is always a push and pull, yeah, right? Whether it's a public research performers or businesses, yeah. All push is there. Oh, what is the purpose of your research? You spent so much of money. Is there any technology produced? Yeah, isn't it? And same way industry, government or universities, they ask industry to fund more fundamental research. Yeah. So this is all push and pull happens. So where our own organization falls in to bridge this particular gap. So in this is what TEAGASC comes in, where we have to fill up both the gaps between applied as well as fundamental research and a commercial research. So the main mission and vision of this organization is to support Irish agri-food sector through science-based innovation. Yeah. So in order to bridge this gap, has to some research. So there is always a push and pull effect. Yeah. Now, in your opinion, what should be the priority? Fundamental research or commercial research? I am not putting an applied in between. Whether we should focus more on fundamental research or we should focus more on commercial research? Fundamental. So that means all the public sector money should be used to know how microalgae grows or how butterfly flies and how different types of technologies work. Yeah. So it has to be the cocktail of both. If you remember, sometimes fundamental research is required to get the commercial answer. Yeah. But you need to have a commercial answer to generate that revenue which can be used to create knowledge. Yeah. That's the way it works. You have a knowledge, you innovate, business starts. Business makes money, business pays tax to the government, and part of that tax is used in educational institutions, all these lights, buildings and everything. Yeah. So whatever fee is charged, that is much more expensive than who bears those costs. Universities are not a business model who is making a profit. Lot of money comes from government, where government gets money from taxpayers, and or tax comes from commercial businesses. Yeah. So this is the way the model works. So best balance between should be there between fundamental, business, commercial research and applied research. So it is often believed that basic research always yield commercial research. But have you noticed other way around? Some research is done, innovation is done, innovative activities or applied research is carried out, and that leads to fundamental questions. When you carry out the experiment, you see why it is happening, that why factor gives you the fundamental side of it, right? So that is what is important, different types of research that generates how or what should be innovation model or a business model, right? Now, who should be at the center point or who should be the priority for the research? Like when we do research, what should be the priority for what? You pick any particular topic. You are working on cheese, you are going to work on wastewater, somebody is working on alternative protein, somebody is working on something. Who picks that? What is the driver? Somebody is working on packaging material, somebody working different one, everybody thinks their area is good, yeah. But in some cases others area, research area is good, mine one is boring. When you start, everything looks good. As time progresses, you think, it's just ordinary one, yeah. So what do you think, what makes the priority? I know you all are employed on some sort of project or some works are going carried out, yeah. Now first and foremost, most important element there is consumer first, yeah. Consumer or your stakeholder or end user. Consumer here is not the person who is consuming it, yeah. So consumer, customer, yeah, take it in the same way. Now, what are the customer? Wholesale, importer, business to business, retailer, food service operators and a consumer. Just take exactly as a food one, yeah. So, first you need to know what customers or consumers they want, yeah, right. Then they want, suppose, value, sustainable, premium, natural, functional products, safe, nutritious, innovative, trusted, authentic food, and then that decides what should be the priority, yeah. That is why before any new product is launched, lot of companies they carry out massive surveys, yeah, to know what people are thinking about it, yeah, and what is their opinion based on they launch a new product, yeah. Or some cases they want to launch a product, but they want to influence the consumer choices, then those things are created, yeah. So, that is why it is important whatever you are doing, where you can be, where it will be used. You make it the technology, where it will be used, blank. You should have clear answer for what purpose it can be used, yeah. Oh, you only these type of people can use it, yes, because that was the target. Gluten free product only for gluten celiac patient, yeah, but unfortunately it is gluten free. People go and buy it like a cholesterol free, yeah, you know, is gluten free is only for celiac patient, and then accordingly you have a target consumer. So, consumer they drive policies, yeah, they say we want to have alternative to meat. So, what way to do? Alternative protein, and that is the way type of research or applied problem or problems are put forward and research projects are formulated. So, how, what we need there? We need, that is, who is the stakeholder here? Customer stroke consumer, yeah, right, A. And consumer for certain product, for example, if you take seafood itself, fish protein is an ingredient, and that ingredient is taken by another company. So, that company becomes the consumer of that particular product, yeah. Then they make that particular fish protein, suppose they deodorize it to make a comparable like a dairy protein. So, that becomes another consumer, and they are making into the beverage or making a product, that becomes another consumer plus customer. So, it is very important to know who are your stakeholders, yeah. That means who will benefit from your research and what type of message they should get, yeah. If suppose you are carrying out some research on omega 3 fatty acid or a fish oil or something, and the consumers are there, like normal general public is there, and you start explaining this is the lipid structure, this is a double bond, this will do this. Is it useful for them? No. That is why some places when you were doing experiment, I said we will add 1% NaOH. 1% makes things easier for general public or industry to understand, rather than going for 0.1 molar, yeah, right. So, always to present the information in a simplest form, yeah, you do not make things complicated. We have enough of those complications. Now, another stakeholder comes in, institutional support, and this is just an Irish context. So, if you see, this is TEAGASC, our own organization, Board BIA, that is Irish Food Board, BIM, Board Ishmara, that is the way it is named, and Marine Institute, yeah. These are the institutes, and Enterprise Ireland comes under Department of Business, that is a different ministry, and all these are part of DAFM, that is Department of Agriculture, Food and Marine, that is a Ministry of Agriculture, Food and Marine. So, that is, instead of calling it as a ministry, all are known as the departments, yeah. So, that is the way the system works. So, again, how the policies are made, like government makes a policy that we have to, like for example, millets, yeah. What are how the policies are set? Policies are set bottoms up and top down approach. You see what is requirement at the ground, then at different levels, and then you concise together. Suppose you need a clean water, you need a good housing, you need a clean street, and then you just come up with a specific objective, and that policy is made, and those policies are imposed, well you can say imposed or said we have to work on these policies, and then based on that everything works out. It is bottom approach, bottoms up, all the information collected, based on rules are made, yeah, and these rules are now implemented. You know, if you follow some of those government procedures, when they create even the budget, they get information from every state, yeah. Every organization is asked to provide an input, what is the requirement, yeah. They all put in their requirement and they crystallize all the requirement, and based on that they develop a whole national budget, and then it is implemented accordingly, yeah. So just remember what is the purpose, where we all fit in within that particular system, yeah. Now previously what was happening, you have research and development, yeah. You carry out a research, you look for market, you look for new consumers, what industry needs, and then you realize impact. When we say impact, in terms of monetary value, yeah. You created a new product, encapsulated, take for example insulated caffeine, yeah, but there is no demand for that, then you start saying, oh this is great, and then you look for market, consumer, and then instigate industry need, and then you look for economic impact. But now things has been changed, yeah. It is moved other way around. What market needs, what consumer needs, and what industry wants, yeah, that drives research, and then that is developed, and then to get the impact, yeah. It is other way around, rather than having research first then to develop it, yeah. Now the focus has more shifted towards development, so that you can have more and more innovation, more and more startup. You have seen that, like why focus is going on startup businesses, why government is putting a lot of money into it. So suppose consumer demand is, consumer is getting more and more obese, so you need a healthy diet, yeah. When you need a healthy diet, so research or developmental work should be focused only on that particular area, yeah, rather than making a product and then looking for the market, yeah. So this you will see, this is not only Europe, everywhere is the same, yeah. So you are inverting the old innovation paradigm. That means research, you carry out the research, you develop it, and then look for market, rather than market what they are demanding. That is again the push and pull agenda, yeah. So that is the way how the innovation things are shifting now. Now this is one of the video, because we in this big large project, one of our colleague or institutional partner, they are developing different types of product, from vegan type product, from fish or seafood. So this was one of those video was created on my request for you guys, and you just hear her out, and how different customer different you know, when we used to have a tape recorders, yeah, current is reduced. What happened?
It will come.
Oof. So as I mentioned about different stakeholders, that is consumer, policy makers, government, and all those investment. So there are these this particular project which you may have, or you would have seen the website, that is Impress. How many of you have seen the website yet? So whenever you get a chance, just open it, you will find lot of information related to that. impress-he.eu, yeah. You will find all those things, because a lot of business companies are involved in it, making business models, and how do we, what is objective, and how what all will be performed. Yeah. Within that context, when you talk about the stakeholders, all these industry, policymakers and all, so what is coming out of the project is not the publication or a patent, those things. Those are there, but also to see how we can change the government policy or how we can add to the government policy or a national or a European policy, right. Within this context, you will see what is the model and how this is being carried out in this context. Yeah, just hear her out.
Have you ever wondered how all of us can spark food innovation? At Impress, our industry-driven project, we are co-creating innovative food products from sustainable freshwater and marine ingredients through teamwork and collaboration. Imagine this: seaweed turned into vegan fish-like spreads, and freshwater underutilized fish turned into delicious, ready-to-eat fish spreads. If you are curious to see and interested to participate in creating these products that are better for you and the environment, dive with us into the world of co-creations. First, we analyzed the latest scientific research and looked on the products on the market. What's working? What's missing? This helped us set the stage for our exciting new creations. Next, we turned to the final experts, consumers. We asked over 1,000 people what is important to them when choosing spreads and about their willingness to choose new innovative combinations of ingredients such as algae or fish. This gave us useful input to create spreads the market would crave. Now we are ready to co-create. Our workshops brought together consumers, scientists, industry experts and policymakers to mix ideas, expertise and creativity. It's all about creating innovative spreads that combine science, market needs and consumer preferences using sustainable and healthy ingredients. How we did it? We started with fun ice-breaking activities like word association and personification, helping participants feel relaxed and engaged. Then we introduced them to the unique ingredients they would be using. All of this sparked creativity for the spreads we were about to co-create together. What makes a spread stand out on the market? First, we analyzed the commercial spreads. What works? What does not meet consumers' expectations? And what could be improved? For this, we used role-playing to step into the shoes of scientists, food technologists, producers, retailers, marketing experts, and consumers. How can we create spreads that are tastier, healthier, and more market-friendly? With these insights in hand, we were ready to create something truly unique. What happened when creativity met collaboration? We jumped into ideation, using techniques like Lego Serious Play to build new ideas for spreads. This hands-on approach helped us think outside the box and implement new thinking approaches. After ideation, it was time to get hands-on and real fun began. We rolled up our sleeves and started making spreads using traditional legumes, sustainable algae, and underutilized freshwater fish. These ingredients, which have nutritive potential and quality, were ready to transform the spread market, which continues to grow steadily. With every combination of ingredients, we brought something new to the table, crafting spreads that are as innovative as they are delicious. What spreads are the future food stars? Which ones have the most potential on the market? Our expert jury selected the best of the best. Now, these rising stars are in the hands of food technologists who will refine and perfect them to the next level of innovation and success. And so the innovation journey continues. From concept to creation, we brought together the power of collaboration, innovation, and sustainability. These spreads are not just products, they are the future of food. Would you give them a try? Maybe one of these spreads could become your next favorite. So, what makes co-creative workshops so special? Participants combine both different perspectives and ingredients, exploring exciting new combinations. Hands-on activities foster creativity and boost ideas into promising food prototypes. Together, we turned underutilized resources into delicious food products. And in the end, or at the beginning, these are moments filled with smiles, creativity, and a relaxed atmosphere where everyone had fun, made new connections, and enjoyed their time together. By involving everyone in the process, we demonstrate that innovation truly thrives through collaboration, where every voice matters. Let's co-create and innovate together.
So, what did you learn from this? Basically, one word came out very clearly was co-creation. Yeah. Suppose a company is designing a car, yeah, or designing any equipment for the user, and they never use that equipment. Suppose a car, take it for example, Bajaj is developing auto rickshaw, yeah, and they are not the one who are going to use the auto rickshaw, yeah. That's why I just moved from car to auto rickshaw. They designed auto rickshaw, made an equipment, and sold it to those guys who are going to really operate it, or consumer who are going to sit in it, yeah. So, will that model be the best one, or you say, oh, they should have given this, they should have done this, they should have done this. You have seen all those type of questions, right? So, to avoid that problem, if you do co-creation, that means to know what they think should be the best one, that is developing by design or design by using the end user into it, right? That is what is called co-creation, is not to develop just any product. You mentioned about vegan product, yeah. So, everywhere fish vegan product is not only related to the fish fillet, yeah. The fish paste is made, pate is made, and what type of product they want to have, what type of their choices are, nutrition and all, what is there inside is another one, right? So, co-creation, that means co-creating things with industry, and all the innovation without co-creation does not end up in commercial businesses, yeah. That is one of the most limiting factor. You are designing a system which is in your opinion is the best one, and no doubt it will be the best one in your opinion, but when it goes to the user, you can't use it. You can see numerous buildings are made, numerous infrastructure is made, numerous airports are proposed without knowing what consumers want and who will be coming in, who will be the user, yeah. So, it whole of the process, lot of money goes wasted. So, co-creation becomes very, very important exercise. Before launching into what type of vegan product we want, we see what people they want to have an alternative for. If suppose you are looking for vegan fish product, is that vegan fish product as a steaks or as a fillet, or just those products which are used as a spread, like as a morning breakfast. They want to eat a healthy fish product, but morning they do not want to have a fish and chips, they want to have a bread spread. So, based on that product is decided, and then to see what are the things what they look into it. Alternative fish smell they are looking for, or fish like ingredients they are looking for, its nutritive value they are looking for, or better spreadability, you know. All those requirements are there, and based on their products are developed, and then it is tested, and then to find where the fault lines are and what improvements are required, then it is created. So, once you have a concept, yes, I can make vegan fish like product, good, then how do you create it, yeah. And in order to instigate the interest, or in order to teach people how to follow that procedure, one thing is called living labs. How many of you have heard this word? This is very, very useful, like this type of video, yeah. The purpose of this particular video was whenever the co-creation activities was carried out, this was recorded for educational purposes to show you guys how it works. Yeah. The same way when you are making a product, if you have a video, like everybody makes reels on YouTube channels. Yeah. How to make biryani, how to make idli, vada, different recipes. Yeah. So this is one form of living lab. Yeah. But same way, this is the ingredient, this is the way mix it. You saw that there 2 videos. That is one sort of living lab. Yeah. That is for educational purposes. Another one is where you bring in the people, like CSIR and different institutions, they do open days, where the kids comes in to see how things are working, how food is processed, how food is dried. All those things comes a part of living lab, and that is all is reflected towards the social responsibility of science. Any school kid comes in, oh, that's a waste of time, I wasted one day of my research activity. Like here, those guys who are helping you, they are also doing the PhD, they have their day jobs, they are involved in this one. One way it can be seen that their precious time is wasted for 7-8 days of 2 instructor time is gone, but that is also a social aspect of it. Yeah. And then now it is, what the heck is this? It reminds me now for the TV debates, you know, somebody is saying something, wait, you answer it. Yeah. Where I was. So that's what I meant by saying living lab. So you also have a social responsibility. So next time any school children are coming in, be actively involved in the process, because that is also the part of education system. Yeah. It is not a researcher, scientist is involved in undergraduate graduation teaching, but it is having a much larger responsibility. They are putting a lot of time and effort to make people educate. Education becomes an important part, and how to educate, that also is another set of questions, right. So basically remember one thing about co-creation. Yeah. Co-creation, involvement of different stakeholders, and how you get engaged with different activity. So you all agree majority of the stuff stops here. Yeah. You started your PhD, you want to find something, discoveries are forget about it. Majority of the research is not carried out to find an answer. Yeah. Research is done straight away. Oh, I have done this experiment, I am waiting for my paper to be published. Yeah. Or I am waiting for my patent to be filed. Yeah. Or IP is intellectual property rights. Yeah. And one thing is important is discoveries. That means certain experiments are done only to find the answers. Yeah. You know the process I mentioned about, if you look into the literature, have you any paper if you come across to show how we get a fish protein without having alkaline extraction. Yeah. Just you read the paper, oh, alkali, add an alkali, get the protein. Yeah. But if you try other things, yeah, it may happen, it may work, it may not work. Remember Thomas Edison, what he said? When he was trying to make a bulb with different combinations, he failed 1000 times. Yeah. So again he started trying. So his colleague said, you are still trying, you failed 1000 times. He said, no, I did not fail 1000 times. I know 1000 ways it won't work. Yeah. So there is nothing as good result or a bad result. Oh, my experimental result is not good. Not good means experiment is not done properly, right? That is what is considered as a not good experiment. Negative results are also results. Yeah. Thing didn't work, that means hypothesis is rejected. Yeah. You think if you heat milk, you will get better quality protein. It didn't happen. So, that is also a result. Yeah, it is not always positive things are published, everything is publishable, right. Now, this is what to do with discoveries, publication, patents. I know majority of you won't agree, no, I have to do the experiment, I have to publish it, yeah, even though they published a paper which they don't understand what they were doing in it, yeah. So, that means whatever experiment they publish, they should be remembering it 5 years, 10 years, 20 years down the road. That means it was done with a clear intent, yeah. Lot of time, oh, I did this paper in my first year, so I don't know what was written in the paper. That means that time it was done not with the interest, yeah. And what was the taking out of it? Remember, any work starts, yeah, this is the trunk, yeah, and this is the end point, start point, end point of a project or a PhD thesis, yeah. So, while doing that experiment, you get lot of different questions comes in a research, yeah. And then if you just try to find answers related to that, this is what will give you fruits. Remember, trunk never bears a fruit, it always comes from the branch. Your task is to valorize the wastewater by using microalgae. If you don't like it, I will change the example anyway, yeah. If you have to valorize the wastewater by using microalgae, in doing so, you realize that the microalgae, instead of reducing carbon, nitrogen or inorganic nutrient, it is taking certain heavy metals out of it, yeah, and accumulating into it at a specific point. And then you say, oh no, that was not my interest is only on BOD and COD, right. And then that can yield into a new area, that means you are able to trap all the heavy metal into one place, yeah. So, these are the findings. So, you start with one objective and try to follow that, and when you are doing all those experiments, keep your eyes and ears open and then to see what is happening, and from there ask those questions, why this is happening, yeah. Try to find an answer in a literature, or else try to do some bit of investigation and then come back to the track. It is something like when you walk in a shopping mall, your target is to go and buy a pair of jeans and you end up buying everything else, yeah. Just because there was offer, this was this benefit and other things. But when it comes to research activity, our focus is I just need to finish this experiment, yeah. So, the way we are in our own day-to-day life, same way we are into these activities, yeah. So, if suppose you started, you ended a research and you got a process developed, yeah, that is basically a patent, for instance. Then if you study the product, for example, somebody is extracting a plant protein, they got the best plant protein, and if they compare that plant protein with existing proteins, looking into the properties, looking into application, that all can go for publication, that is studying the solution, yeah. And when you are extracting those protein, you have done number of different trials and errors, different experiment, tried alkali, tried this alkali acid and different permutation combination, and you got to the solution. Then go back and each and every trial you did, you just investigate those, that is studying the problem or studying the solution can be easy publications, yeah. An actual solution can be IP or a discovery or intellectual property. So, everything can be done. It is not my work is commercial, I can't publish it. That is not true, that is an excuse, yeah. Obviously, why you will be publishing a specific conditions, yeah, but studying the impact of temperature on coagulation, that is a study what creates the knowledge, yeah. So, it is not that if you focus only on output driven, then you will never be able to achieve those things. If you remember that shlok, keep doing the job, don't worry about the outcome, or any work done in anticipation of an outcome is not a work, yeah. So, once you have research output, next one comes research transfer, that is engagement with the end user, yeah. Once you have created a process, created a technology, then you have to engage with the end user. End user can be your consumer, customer, business to business, depending upon what are the stakeholders. So, what are the main research outcome of any project or any activity? You develop new product or improved product or processes. Yeah, when we use new technology, we are improving the processes. Yeah, you create a new service, software development or other one, or you make entirely new process of doing things. And then how do you establish the impact of that work? How do you quantify? You spent €1 million to carry out the research project for 4 years. What was the output? We got 3 papers. That's also good. You have created a knowledge there. Yeah. Apart from your own benefit, somebody got employed for 4 years, somebody got a promotion, somebody got this. What is the research impact? Value added improvement, economic benefit, social benefit or environmental benefit. All those benefit what funding agency, that is government, is looking for from the research. Yeah, that is very important. Then you have national and international benefits. You understand how we can create carbon neutral environment, or take example of vaccine itself. Yeah, when all the money was added into the vaccine research for COVID, what they looking for? Publication. Main was benefit, social benefit. Yeah, so everything which is added into the research is not or should not end up here itself. So one is linear model, but more complex in real world. We all know that. Yeah, varies according to discipline. Some are tangible, some are non-tangible. When you mentioned about qualitative and quantitative one. Yeah, historical research to understand how people decided how a country emerged, that is qualitative one. Yeah, or non-tangible one. Some places you have tangible, takes time, but there may be intermediate outcome on the way. Yeah, you are developing a system. Suppose you know all those moon mission and all those big rockets which were launched into Mars mission and different missions. It takes 6 years, 7 years. Yeah, so that is also research. They are not the one who are looking for publication. It takes time. Everybody knows it takes time, but that should not be taken as an advantage for the researchers. Yeah, researchers are not the one who are 9 o'clock coming on sitting on a computer like a bank account and goes in the evening. So it is 24/7 activity. We have to keep thinking. Evidence, need to monitor and collect evidence at each and every stage. That means observation. Yeah, observation is the key. The person who discovered radium was discovering something else. If you see Marie Curie's biography, yeah, radium was accidental one, but only because of observation it was obtained. Yeah, same thing happened with the carbon. The last 2 years ago, the Nobel Prize was given for somebody who was having a pencil scratched onto the paper. Yeah, if you know about graphene, yeah, thin layer of carbon. What was the experiment? Rubbing the pencil or having a tape. Yeah, if you go and see, last it was from Manchester in the UK, the Nobel Prize. Who received the Nobel Prize? It was not making a rocket or so. It was mainly experiment was a pencil, lead pencil, scratched on a paper and with the sellotape to create a graphene layer. Yeah, so that's also there. That means somebody was sitting on a table and the same thing got particles. Yeah, so all those things were based on just observation. And we all are in hurry, so we call hurry makes worry. So that's to understand, does your research makes an impact? Yeah, it is self-propelled impact. Oh, I am doing this, this will solve this problem, that problem. No, just talk very, very specific one. Ask any question. Oh, I am working on this one because this will be more sustainable for the environment. That is non-tangible long-term impact. Yeah, but what is the immediate impact what you are solving? Yeah, that is immediate problem what you are sorting it out. Now, public funded research, this is from Cunningham and there, this is 3 helix one. Who are involved? Government is involved, university is involved and industry is involved in these activities. Scientist who takes a role of publicly funded principal investigator, that the person who is dealing with the project, are the linchpin of the knowledge transformation through articulation of research programs, shaping of the research avenues, bridging the academia and industry. That means the person who is running the project is a principal investigator. He is having one PhD or a 2 PhD working on it, or there is another postdoc or a research employees are working on it. But his main thing is whatever different people are doing activity, how to take that information and transform into real activities. So, in most of the cases after PhD, how many of you have heard this word postdoc? Yeah? What does it mean? Postdoctoral fellowship. Yeah? If you read this word carefully, that is called, one thing is post-mortem. Yeah? But what happens, PhD does the research, postdoc writes the paper. That is completely wrong structure. Yeah? So, whatever research is done to see what you got and what further investigations are required. Where the question is, oh, you have done this, I am not having some good analysis, get SCM images, get this one, we can publish a paper. Yeah? That is wrong way of doing it. Whatever is being done, to look into it, what extra analysis will add value to that work, or what new area of experiments can be carried out. And then that is called post-mortem, that is analyzing the study, because one has already completed that particular task, PhD is finished, and then he moved to another one, right. So, that is very, very important when it comes to PI. That is why I just read a quote from this particular paper. Other one, PIs at the macro foundation level are the nexus or interaction between triple helix actor that influence drive research agenda. Now, it is a quadri helix model there, and the fourth element is also added into it, but I do not want to go too deeper into the philosophy of research and the science. There are number of different journals who are only focusing on these type of things. Yeah? That means, if research is done or research is carried out, your responsibility, what your task is to carry out the research in a given project, get the data, publish it, or to find an answer to a question, right. Postdoctoral question is to see whatever is done, whether you should publish it or you should protect IP. Yeah? So, that is you all know, I am not going to go in details of it. So, in addition to scientific excellence, these are very, very important. Any research what you are doing, shaping your research priorities. What should be the priority area of research? Shaping the ethos of research integrity is very, very important. Is not just to do it, do the minor adjustment here and there and publish it. Yeah? Or I am talking about all those not illegal, well, whatever activity you want to call it, forging the data, creating the data, yeah, that is against the integrity. Yeah? That is called slender theft. That should not be done. Let it be wrong. Yeah? Redo it, let it take time, but modification of any such thing is no in any case. Yeah? Because that is something like crime. If you are working in a bank, stealing 1,000 euros is the same thing in a research, that is also called thief. Yeah? Forging a data is equal to a crime. Yeah? So, that is taken very, very seriously. Think of you are doing research, that is okay, nobody is crying and all. Suppose if the medical research is there, somebody forged the data and published the study, and somebody adopted that particular formulation and killed 1,000 people. Yeah? That is why it is a crime, whether it is any research, whether it is a food research, medical research, or any research. All research comes from the same money. Yeah? So, that is why this is really important. So, when you are doing work, make sure these are there. You are shaping up research priorities, but whatever work you are doing, how that can be instigated into further work. Ethos, that is integrity. Fostering interdisciplinary activities, transdisciplinary or multidisciplinary. That means, when you are talking about, again, microalgae is biologist, wastewater, environmental engineers, designing the system, process engineers, you need different streams, knowledge of different streams. That is why sometimes I call it as a food science is a common science, which is not so common in common people. Yeah? So, you need to have a knowledge of all the discipline. You can't be expert of each and every knowledge. There is no harm in seeking opinion. And second thing comes in, oh, why should I take an opinion from this person? He is only first year PhD. I am senior PhD. Why should I ask this person? He's just doing the first year BTech, yeah? Because egos comes in between. Whether the idea is good or bad, it depends upon who is saying it, yeah? Same thing if your boss or your line manager is telling you something, you just readily accept it without arguing, yeah? That is another bad thing. You either get convinced or convince. There is nothing in between, yeah? Either you convince somebody to do something or you get convinced, yeah? So there's nothing in between. So you should know what is your current strategy. Prioritize areas of possible exploitation for your own research expertise. So these are pretty much the same, and it's coming into how we can achieve scientific excellence. So coming back to the same diagram which we saw the other day, right? This is the basic research, most comfortable one. Go in any time in a lab, do the experiment in beaker and test tube, that's fine, yeah? Even sometimes if you think about agriculture experiments, people who are working on agronomy, forestry, they grow a crop taking 1 year data, and all of a sudden heavy rain, flood, tsunami, gone, yeah? So that's also another issues are there. So whatever research we are doing, to see how we can transform into a commercial activity. So if you want to see more details about each and every level, what does it mean, what is included, what is not included, that is you have to go on a website of NASA, and that's you will see TRL levels, technology readiness level, NASA, and you will find all those stuff, yeah, okay. So obviously this is quite complicated, we have already covered that. So you understand what is and what does this arrow indicates, yeah? Basic research, when it goes to innovation, yeah? Innovation transformed into commercial research, yeah? And from there other problem comes in, and then to modify it, yeah? So that's why this is the area which meant maximum amount of revenue, maximum amount of money. This is input, money goes into this one, and from here money comes out, yeah? So that's why everything has to go to the next level. Now what happens, you'll see this is one of those, if you go into this, that is Bioeconomy Research Center, yeah, and I am one of those PI of this big multi-million euro center. This is biorbig.com. If you go into this, what is the engagement model, because majority of the work is related to industry and transferring the project to industry. So if you see any new project what is started, principal investigator, industry, we discuss what is required, and EOI, what is EOI stands for? Expression of interest, yeah. Industry says we have, this is the problem. We have a researcher, he says we can solve the problem by doing A, B and C, a sort of co-creation activity, and then project is developed, very short project proposal is developed with industry, we get a feedback, reviewed, and then contract signed. So this is the model where industry is engaging directly with the researcher, yeah. It is not that funding call is out there, you write a proposal, you submit it, yeah. So that means applications are developed based on industry requirement. Lot of these things are also happening in different institutions in the country. Industry comes in, wanted to meet a researcher, I have this problem, concerned researcher, oh we can solve this problem by doing A, B and C, yeah, and then they develop a proposal, contract signed, and works start, yeah. So that's one. Now what happens in case suppose what I mean by TP is targeted project, yeah. That means it's very simple target project, I'll just open it. When you start a project, what do you get? You can put your PhD project also here, right, yeah. Because the whole purpose was to show how we are engaging with the industry and how do we make innovative model. You have any project, even a PhD project, what do you get? Data, yeah. And what with data, what you do is whosoever is involved in it, If it is industry project, discuss each and every data with the concerned PI, PhD, postdoc or other stakeholders involved in it. Yeah. Then to see whether you can protect IP or is just the knowledge which has been created. That is the point. You should see whether you should go for publication or to engage with TTO. What is TTO? Technology Transfer Office. Yeah. That is, some places different departments are there, IP departments are there, business development or extension department, you know, they are named differently. I am just talking about the model, what is there with us, what are the departments here. And then IP is protected, and once patent is granted, and in our place you cannot have a patent filed unless until there is a buyer. It is like, you know, you see that in China and other places, oh, I have 75 patent, 85 patent, but how many business started? No, in Europe you can't do that. Patent is only filed, we call it IDF, Invention Disclosure Form. Yeah. So when that gives a number, because filing a patent costs very heavily to the exchequer. Government has to put huge amount of money to file a patent. Yeah. So we only file a patent at European level, national level, or sorry, European level or international level. One, there is a person who is buying it. Yeah. Who is interested in to carry out the pilot scale activities. Then the licensing agreement is done. Yeah. And almost every patent has led to one business, and those companies are made and sold for a couple of millions and billions to other bigger companies, right. It is not the patent is there, who is using it? Nobody is using it. Yeah. So that is why the engagement model works. Do you think any improvement is required in such model? There is always chance of improvement. Yeah. So this is one of those engagement model. Moving forward, I will give you this example again, coming back to the company marine one. Yeah. You have already seen these ones. Yeah. Now this is all when aquaculture was done. These are some of the people went into the sea to see where when the seaweed is grown, you know, with those ropes. Yeah. It is not at the shore. We have to go deep in to get at least 500 to a kilometer in to see those ropes. Harvested and all those things what was done in the lab, and this is all done in pilot scale. Yeah. I can't identify those guys. And then you have, these are the guys who were developing hydrodynamic cavitator based on the requirement. Yeah. You saw the machine previously, and then all those operations, and then pilot scale, very same man who is here, and this is coming out of a spray dryer, 800 liter per hour capacity. Yeah. When product is made, 800 liter per hour capacity is a huge one. Yeah. That is the spray dryer which obtaining a product. And then this is Anuga. It's not the name of a person. It's just the biggest food ingredients event, happens once in 2 years or once in a year in Geneva. Yeah, where all the companies from the global market they comes in, and then there are investors and the people who are launching the product. It's the same company as mentioned about Nutramara. Yeah. So all these activities, it was not done in one day, right. It is not done in 1 year. This took around 5 to 6 years. Yeah. And work has not been stopped, it's still going on. Yeah. Now to look into different applications. So you have already seen this. This was started with, yeah, and you have seen all the biorefinery processes. Whatever I was covering, all the examples were associated with fucoidin, algal fiber, carotenoids and other ingredients. Yeah. And then what is out there in the market. Yeah. So any questions so far? Now I'll quickly run through these few strategic documents before we go on to the next one. Is all to do what are the innovations, and all these documents are freely available, though they are quite old, not very old, but still they hold the value. Some places you don't know what direction you have to go, what is the innovation route you should be taking. mission oriented research and innovation in the EU, a problem solving approach for fuel innovation led growth. Very nice document which shows how you go mission oriented approach, what should be the approach, that is also very important, right. Again same thing, future scenario for research innovation policies, and why European document are some way better. I am not promoting European document compared to other places, because this involves multiple countries. Yeah. Any policy document made in India is exclusively for Indian subcontinent, right. If it is done in US, it is for exclusively for US. European documents are made by combined activity of 28 different countries. Every country is having its own primary requirements, right. So, it takes lot of time, lot of brains have gone in to make a document. So, everything comes out in a very plain language, yeah, so that everything is understandable. And you know all about United Nations Sustainability Developmental Goals, yeah. So, what we will do is when we come back, we will have a quick recap, and then we will just go with pretty much the last one about the publication strategy, and we will quickly run through about IP and how do we publish it and how you can publish good papers out of it. Yeah. Time out. So, so what we have discussed so far about innovation model, IP or some of those stuff. So, we will cover again with the publication strategy. That means not only for publishing papers, but also to do what is impact and how do you realize the impact. So, remember two key messages. One is from Bill Gates. I believe in innovation, and the way you get innovation is you fund research and you learn the basic fact. Yeah. When you work on a dairy processing, you learn the first basic fact, how to make yogurt, which your grandmother's grandmother is making since ages. Yeah. Now, this is one of the most important thing what I always keep saying. If you can't explain your work to a 6-year-old, you don't understand it yourself. Yeah. That is the most important, and we always try to make things complicated and always try to keep things as simple as possible. Yeah. If you make it simple, you will understand and you will make other people to understand. When they understand, then only they can use that information. Yeah. Otherwise, they will come, oh, it's too scientific, they will get away. Yeah. Now, so most important thing is when you are doing any work or anything is to do proper planning. I did mention this one, we do not plan, we start believing only in execution part of it. Yeah. Think of any of those weddings you would have attended. Yeah. How long it takes to plan, each and everything is planned. Execution is 1 day or 2 days, that is it. Yeah. But planning starts 6 months before or at least a year before, to book a marriage hall, to arrange the caterer, to arrange everything, accommodation, who will come, what type of stuff, right. So, when it comes to experiments, Monday I have to do experiment, and then you start doing experiment and then say, oh, I need this, then you are running pillar to post. Yeah. Then failed. So, experiment fails only because they are not carefully planned and SOPs are not developed. You just carry on. I have seen people taking a research paper and underline some of the stuff and goes into lab. How long does it take to copy it from there, put it on a computer and make your own SOP, what you're going to do, how long you're going to wait, and then don't deviate with it. Yeah. While doing so, you just make an observation, make a note of it, and then when you do next set of experiment, then you can do the variation. There's no point in changing while doing the experiment, so that you don't know what is making an impact. Yeah. Right. So that's why consistency becomes important. Planning and design becomes important, and then once you execute it, and when you executed, you took all the observation, and then you monitor what went wrong and what could be done better. That's the way, keep improving the stuff. Yeah. So that becomes very, very important. Starting is not a problem. Planning, execution, and taking a feedback or controlling what could be done better. Yeah. If you are doing any extraction, first one, you just carry out one single extraction, then you see what are the problems, and then can you do 5 extractions together. So that way you can save your time. Yeah. Starting a very big massive experiment in first place, or take for example shelf life experiment. You have to take a sample at regular interval. Yeah. And then suppose one day data is gone. Yeah. Suppose you have to go on holidays or something. Then you don't have to remove everything. Then you can keep some extra sample in case suppose something is, you presume that shelf life will be 21 days, but at the end of the 21 days still the sample is good. So to plan in such a way that to keep some more samples for further experiments. So this becomes really important. Everywhere, why you are doing it, what is your priority, yeah, or what are your priorities, yeah, that is very important. Doing an experiment to extract a protein, or doing an experiment to get answer to some question. What, when, where, who is going to do it, how you are going to do it. Any planning. Yeah. Why I am giving reference to non-research examples, because these are the ones which we deal every day. Even you guys coming in here for this particular course, you travel from different parts of the country, and then you all planned it, isn't it? Execution was just to sit in a train. Buying the ticket, purchasing whatever you needed, your clothing, packing, everything, that took a time. Yeah. Travel time was 10 hours, 12 hours, 13 hours, whatever it took. That was the execution part of it, right? What you are going to do there, when you have to go there, where you are going, whom you are going to meet, and what are your plans over there. So these all questions are important. Now once you get model done, execution is done, then what worked, what didn't work. Yeah. What worked comes as a best practice. What didn't work, you improve that particular work. So there is always a continuous improvement. Remember, those who do work, they only do mistakes. Those who don't do any work, they don't do any mistake. Yeah. So now this is what I'll quickly go through, as I mentioned about technology transfer office. How do we create impact? Yeah. So we have a dedicated office everywhere it is, like TTBD, Technology Transfer Business Development, and all those type of departments, and are there or extension services, agriculture universities, they have a lot of agriculture extension. That is, how do you transfer the knowledge to your stakeholders? So how do you create an impact? Commercialization within the innovation cycle. The idea what you have, yeah, any idea in a form of project or so, you carry out a research work. Yeah. You get the result, you create IP, intellectual property, or data for publication or for patent. Once you have IP, you commercialize that work. Yeah. That creates job, generates revenue. Yeah. Starts the business. Yeah. So this is one simple innovation cycle. Yeah. But from idea to company cannot start straight away. Yeah. Whatever idea you have, you know what, we can do this way. Then you prove it, yeah, by doing the research. Then you prove it, you reinforce that one based on the results what you get. It may be positive, it may be negative. So that is all. When we study statistics, you know about hypothesis, null hypothesis, disapprove hypothesis. I am pretty sure everybody has learned about that one, and we never use it. Yeah. That's why sometimes when you go and present your research project, nobody will start that my hypothesis is this. Yeah. Nobody does it. but that was the fundamental way of dealing with it. And eventually you will be using it at some point depending upon wherever you are. That means what is the basis of your idea? So this is what innovation cycle means. One, now this is all funding, or this one all related to Irish context. Impact from research. You get additional funding. You got a research, you got your data, you discuss your idea or whatever data you have after protection with the companies. Oh, that's a good idea, we want to hire that, or we want to adopt that. So either you go and work in that company, a lot of time it happens, yeah, or you get additional money, or you get additional funding from different departments, yeah. There are a lot of different case studies, different examples are there from NIT Rourkela as well. Or you go for commercialization fund, that is get a money from the industry to commercialize your research activities. Engagement with industry to increase adoption. So if you have improved process, you talk to the industry so that you can accelerate adoption, so that they can sort out the problem. Take for example, all the straw which is burnt in a field, yeah. So if you have idea and then is a better way of utilization, farmers' problem is they don't have a time between A crop to B crop. They want to get rid of it quickly. Even though you have a best process, or you have some way or the other recovering it, and then to prove it on the field, that is demonstrating on the farm, yeah. So that is quite challenging to convince other researchers, or sorry, to convince researchers, even the people who are going to adopt those technology. They will say, ah, these are all kids, I've been doing the agriculture so many times. I'll quote an example. We were doing some extension activities back when I was doing my bachelor's in Pannagar. We were having extension in western UP, and then say, oh, what do you do? We study science. So he asked a question, tell me this earth rotates? Said yes. No, that's wrong. I've been living in this house for 35 years. The door was always east, never went to west, yeah. So you're dealing sometime with these type of people, yeah, okay. So same type of question, when there is a thunderstorm, when there is a lightning, and you have simple explanation, when a cloud hits mountain, the thunder lightning is there. So he said, no, you're wrong again. When it rains, rainwater touches the earth, it goes and gets what you call earthing, and then sparks happen. So they say, no, thunderstorm happens, lightning happens without rain also. They say, again, such a big earth, somewhere it may be raining, yeah. So you are dealing with sometimes those type of issues, and you come up with a new process. They say, oh no, I've been doing this business for 20 years, and you just started and you're talking about it, yeah. So you have to convince in a most placid manner, so that your message goes across. That is what asking people to adopt that. If they are not adopting, then the policy is changed, then they are forced to adopt it. For example, the wastewater, why all this duckweed, microalgae, seaweed, all these things are coming in? Because government made a law, any industry dumping the water into the river should have A, B, C, D specification. That's it. Then what will happen? Everybody will try to find a solution, yeah. So sometimes things are made based on law is created, so your research either influences industry to adopt the practices, or you make a law. Other one is your own career advancement, that is you start your own startup, progression, promotions, or listed as an inventor or invention disclosure form or a patent, yeah. So this is what is for you. It's not that you do anything creative work, you don't get anything, you get what is there all for you. If you are already a researcher or permanent employment, this is what happens. Your career advancement or financial reward. If you are involved in a patent and patent is adopted by industry, you get financial remunerations. Or if you are your own inventor of a patent and goes to industry, this is the easiest and cleanest way of making money, yeah. Lot of people, they earn a lot because of creating patent. That's what you have, that stuff, that you have a knowledge and you can create, use that knowledge to create innovation, and when you create innovation you make money, yeah. So that's opportunities. You grow your network when you engage with industry, you get new funding route, what you have already seen. You achieve your real world impact. You are called scientist, but if you can't solve a social problem, then it's not a scientist, yeah. You are very good surgeon, you are very good doctor, but you cannot treat a single patient, you cannot solve a single patient's disease or a problem, then is not a good doctor. Yeah, it doesn't matter how many degrees, FRCS, DPCS and whatever degrees A, B or C has done it. Policy promotion, career and promotion. What are the concerns? First one is confidentiality. If you work with any industry, you have to be concerned with the confidentiality of that information. Even if you have supplied the patent, you have sold a patent, you have provided an IP to an industry, you have to go with confidentiality of it. So, most of the industry they sign NDA. What is NDA? Not the political party NDA. Have you heard of this word? Non-disclosure agreement. Because when you have a policy, when you have a process, it has to be adopted in industry. They have to tell you their process. Yeah. So, you know their process. So, it is your responsibility that you do not leak that one to somebody else. Yeah, like a competitor. So, that is another problem. Managing expectation. When you talk to industry, oh, you can solve this problem by doing so. So, immediately they start building things. Oh, wow, I can make this much amount of money, I can do this. So, managing their expectation is also important. So, that is very important to say what you can deliver. Say 4 things, do 5, good. Say 5 things, do 4, or say 6 things, do 5, not good. Yeah, because we always look at the problems, not what is there. Think you have a nice 10-course meal, in a corner one recipe is bad one. Yeah, the entire focus is only on that recipe, not all the good things. Yeah, that's another one. Scientific independence. Yeah, publication. Sometimes you are unsure whether it goes to industry, you are not able to publish it. Yeah, what is the benefit you got even it sorted out the problem. Yeah, so all these things are some of the concern, but all these can be addressed. Nowadays, the funders, that is public sector money, there is a big debate whether the public sector taxpayers money should be used to carry out the research activities at fundamental level or applied level, or to solve real life problems. Yeah. So, they are having a lot of expectation to involve industry. Some places to involve industry for the sake of involvement. Other places it is a real involvement. Yeah. Real involvement, that means meaningful engagement, that means they are going to take the result, it is not only the support letter. Yeah. So, these are the important things when we engage with industry. So, you are IP creator, you create IP, you disclose or you protect and you manage. So, it is not expected that I alone can do all these things. So, for that you have to take a help of a technology transfer office, but it is important to be aware of the process. Yeah. So, that is what you are creating by doing research. You disclose this one either by IP or by invention disclosure form. This is the policy what is adopted at our place, and it is very robust policy. Who owns the IP? Even the IP is sold or given to the industry. In Europe, if IP has been created by taxpayers' money, that IP remains with the organization. There is an IP policy, and you would have seen that all those discussions are there, IP transfer, intellectual property and all those things, you know, like you have seen in the media. Yeah, intellectual property right, these are governed by international laws as well as national laws. Yeah. So, these are all bigger thing. I just wanted to make you aware how it is created. So, support research, entrepreneurship, strategic collaboration, industry engagement. So, this is all how our organization or engage at TEAGASC, that means Technology Transfer Office, operates. There is a Technology Transfer Office also in NIT as well as in different institutions. Those guys who do, how many of you have studied this program, Critical Path Method or PERT? Yeah, Operation Research, you would have studied in under masters. Yeah, all those things coming in within remit of that particular department. So, I am not going to go into this in detail, but this is the way how we engage with industry collaboration, developing a new companies, startup or commercialization of that particular research activity. Now, coming back to the publications. So, in your opinion, who is effective researcher or who is called as effective researcher? Those who do research, everybody does a research. Even 6-year-old kid does a research. Yeah. you test it, like you buy 3 mangoes, are there? Oh, it's not sweet. That's also research. Yeah, everybody does a research. So what does it mean? What is a definition of effective researcher? A. Second one, how many of you know about impact factor? Impact factor is of a journal, right? Citation, number of times cited. H index, field weighted citation impact, right? So these are some of the parameters what you see whenever it comes to publication domain, right? But now new system has come into existence, that is DORA, Declaration of San Francisco Agreement. Yeah, that means there is no value for impact factor or citation or so, but what is the impact of that research? Yeah, so these terminologies, they come in and they go. What remains is the quality of your research work. Yeah, if you focus now that I want to publish in high impact factor, why? If your work is related to applied research, how you will going to go into the nature? Yeah, right? The same way, even if it goes in the nature, it's having no value there. Yeah. So now, an effective researcher is defined as a researcher who has published an average of 5 or more science citation index or science citation SCCI papers every year for last 5 years. Yeah. This is one of the definition. That does not mean today you started your research work, after 12 months you should have 5 papers. No, right? This is over a period of time. Yeah, and that also depends upon if you are core into fundamental research, core in applied research. So this is all one of the way looking into it. So if you'll see all the organizations, there is publication per individual. Yeah, it's not that every person will be involved in this. This is one of the definition who is involved in research activities. Yeah, and this publication also is your conferences, science citation index, that is all those which are indexed into a journal, not any journal. Yeah, it's called international journal or national journal. That's no definition called international journal. Yeah, then international, that means Pakistan Journal of Food Science and Technology and international journal. Yeah, even Journal of Food Science and Technology, oh, that's a national. No, it's not like that. The journal who is having is cited into science citation index, that is Web of Science, where all the journals are there. Second one is impact factor. Yeah, that is number of papers a journal is publishing and number of papers cited from the preceding year creates the impact factor of a journal. Yeah, so suppose year 1 they had 40 papers, year 2 60 paper, and year 3 100 papers are cited, and then impact factor becomes 1. Yeah, so it takes 3 years for any journal to get an impact factor. Yeah, so that means that's one of those criteria for impact factor. Citation is a bit tricky. Yeah, it is something like you have 500 shirts, but you have only 5 shirts what you can wear outside. Yeah, so citation is number of papers cited number of times. Yeah, if you have 100 papers but only 10 of your paper are cited 10 times or more, H index becomes 10. Yeah, and if you have 1000 papers and only 12 papers cited 12 times or more, yeah, then it becomes 12 H index. Yeah. Now the problem here is, it's not that you write another paper, keep citing all your paper. Then it comes a problem of self citation. Yeah, and now this is not considered as a correct activity. Yeah, and that leads to your blacklisting. Yeah, or retraction of your work, and retraction is not a good thing. Yeah, and that remains on whatever you write, whatever you publish, remain on the public domain forever, for rest of your life. Yeah, you would have known that if anybody is said like, oh, he or she is going to be chief minister, new chief minister, what happens? Everybody just start looking into their old record. Yeah, same way, the day you are okay, the day you become a director, vice chancellor, or having a strategic position in any of the organization, straight away your old work will be taken out. See, the paper was retracted, gone. Yeah, So that's why it's better to have a right foundation, right ethics, and to have integrity in place when it comes to work. Yeah. So this is again coming back self-citation, and sometimes EICs, they also have issues of forging the impact factor. That means asking or using the same journal to be cited. Yeah. Then it called self-citation of a journal, and then journal is removed from SCI list. Yeah. So what is the bottom line? To do the best quality research, have all the backup data. Yeah. Because a lot of papers are retracted because somebody is trying to repeat it and it's not working. So you have different excuses. So if your backup files can be asked from the journal. Last one is field weighted citation impact. What does it mean? You will see it in next slide. So okay, I will cover this, and then when we go into that particular slide, field weighted citation impact is if you take all the publication published globally in a given area, yeah, and total citation, field weighted citation impact 1 if your work is of international standard, yeah, and if it is 1.2, that means your work is 20% higher than the global average. So if there in a given area, for example agriculture sciences, there is 10,000 papers were published and they were cited 10,000 times, yeah. So this is 1, and then if your area of work in that particular domain is cited more than that, so that accordingly field weighted citation is calculated. A lot of different statistics are coming day by day for evaluating research performance. Now when all these things comes in, this is very interesting cartoon to see where you stand. We all can classify ourselves into any of these 9 categories. First one is a big talker. These results have a clear implication for the cure of cancer in our lifetime. My work is so and so. This is a big talker, right? Slave driver, 60 hours a week just isn't going to cut it in the lab. You got lot to be done. You forget your name, spouse name and all those things, right? Demigod, power, prestige, better job prospects, yeah? Why you do this? Other one is control freak. Why didn't you use 25 millimolar of salt in a second wash? Yeah, whatever you do, there will be always somebody to have to control or to give a suggestion there. Science wonk. Why don't you try this newly reverse gyroprismatic amplifying DR technique? Yeah, that means he knows a better one. How many of you have you watched Big Bang Theory? Yeah, in a similar way, like I say, oh, why did you try this? You should try some complicated technology. Laid back, make it quick. I have to go at 2 o'clock. Do it quickly. Yeah. Other one, psycho. What do you mean? You made a mistake. Yeah. Small town grocer, happy with his own niche area. No. Whatever I am doing, I am happy. Yeah. I don't want to change it. I just have to extract the protein, I will just extract only protein. I don't want to change my experimental plan. Yeah. Other one is rising star. Exciting, right? That means trying to take all those different inputs. So you want to see further more detail, go into this science magazine and you can classify where you stand, yeah, or where you fall in self. There is nothing, is there any other category which is missing? Yeah. So this is what you have to classify yourself, and then you decide whether you really want to be in a research or you better find some other career path. Yeah. Because at this stage we all do what people they suggest. Yeah. What you are doing? Engineering science. Without that nothing is there. Yeah. So, but that is not the reality, right. So, so you can classify yourself and see where you can improve in yourself. Remember one thing, if suppose there are number of hurdles on the way, yeah, and you are here, yeah, and your destination is here, right. So if you have lot of hurdles, you can maneuver around this hurdle to reach your destination, right. But if there is a very small stone in your shoe, you can't even walk an inch, yeah. That means first solve your internal problem before talking about the external problem. Yeah. You need to know about yourself before you start worrying about the external problem. There is a saying, whole life I was cleaning the mirror, but dust was on my face. You've seen that phrase, yeah? Lot of times the politicians are using these ones, yeah? So these are some sayings which are really having a deep meaning in it, yeah? So now this is actually what I was talking about, field weighted citation impact. So if you'll see here, total research output, yeah, this is old data, citation count, number of authors, yeah, and field weighted citation impact, yeah, has been calculated. Now whereas if you go with the specific area E28, field weighted citation impact is 1.24. Okay, first one, it means total number of research paper published in, this is not nothing to do with the TEAGASC here, between 2013 to 2018 were 16 million papers were published, yeah, right, by 15 million different authors. So if you divide that way, you get field weighted citation impact, that's the global average is 1, yeah. So number of citations, so you can think, you get 10 papers, 20 papers, 30 papers, 100 papers, what difference is it going to make, yeah? There plenty of papers are there. Now if you take EU, within EU 5 million papers were published, yeah, in the same time zone 2013 to 2018, and you can get it this one from SciVal, yeah. So lot of places, lot of institutions, the moment you apply somewhere, first thing what they do, they go to SciVal, look into the individual, where he stand, what is the area of work, accordingly they do rest of the thing, doesn't matter what you write in your CV, yeah. Then authors 3.5 million, yeah, 3.5 million is 35 lakhs, right. Field weighted citation impact 1.24, that means European research is almost 24% above than global average, yeah. And then if you go to like that, you can calculate for India and other organization, but this is only a global picture. So every country invest into science and technology so that they look scientifically much more advanced. They want more and more educated society and scientifically educated. So that is why all the money, how the money is spent on different research activities, all those lab based, otherwise every money can be used for businesses, yeah. So that is the way field weighted citation impact is calculated. Same way individual authors can be calculated, yeah. So I am not going to go into that one, the moment you go in you will find it out, what is published, how many people they viewed it, where the paper is getting cited, somebody did the work in Delhi and it is cited in Chennai, national impact. If it is that one has led to a new area of research in South Korea or in Latin America, that is your trend setter, yeah. That means you are creating a new area of research. So all these things collectively are assessed individual how impactful the researcher is. It is not only to do with the publication alone. Publication is something like you have take it, if you studied physics, chemistry and maths. In physics you got 40% mark, yeah, or take it as 33% mark. In chemistry you got 33% marks, in maths you got 34% marks, you passed, yeah, you got 100 out of 300, yeah. Other person got physics 10, chemistry 10, maths 100 out of 100. Whom you will choose, yeah. So this is what happens. So you will go with the consistency, yeah, not with one particular criteria, yeah. So impact is not only with the publication, but it's too early for you to think about that one, yeah, but just remember that fact, because long term vision and to have to do work. The crux of the message what I wanted to communicate here is just maintain the quality of your work with full integrity. That's the crux of the message. Not to bug down with the, oh, I have to have publication in this impact factor journal, I have to have a publication in this journal or that journal, yeah. Even though you hear these things, that is important, but not to follow the wrong way of getting there. Your parent says get job, get rich, yeah. You can get rich by getting working honestly. Another way is by robbing somebody or robbing the bank. So, which route is better? So, same thing, robbing a bank and cheating in publication or research is the same thing. Yeah. Now, why do we publish? First, establish your own ownership and a priority. Yes, I did this first. Yeah. So, you publish it to have your own, establishing your priority. That is why sometimes when we start discussing any of those one like novel technologies and all those things, we say who defined it first. Yeah. So, it is not sometimes to claim or write something without having proper proof. Earth is flat or earth is round. Who said this without going on to the moon? Based on certain facts. And then 100 people, they get engaged in that activity to prove that he was wrong. Yeah. You do some experiment, you prove it with the data, other people, they start disproving it. Yeah. So, that is the way research works. So, be prepared for criticism. Second one, certification, acknowledgement of the quality of the work through publication in a specific journal. Dissemination, inform your peer group and others. For example, you did the evaluation of wastewater across country, you got the data, you publish it to inform the public what is the status of the wastewater. Yeah? That is also important. You are not developing a machine, but you are creating a knowledge for dissemination purpose. Providing a permanent record of your work, making archives. Yeah? That means whatever you do, so you have a record. You write a thesis, electronic or digital form, even if you go to the library, you will see the thesis of 1950s, 1960s. Yeah? And that too, even handwritten theses, typewrite theses, is not like you used to have a typewriter. I know I have seen people, I have seen the thesis which is handwritten thesis, big thick thesis is written by hand. Yeah. So, all those things are there. Now, things are much easier. Yeah. You just write a computer something wrong, erase it and type it again. Think if you are writing it whole page, you bought expensive page, then you have to tear a page and then write it again. Designation, publication record is obviously important, whatever work has done. This also helps a society, whatever you have done, so that they know what you created, to what level you stopped it, and how other person can gain from there and start a new work. Motivation, this is one of those survey. Survey was carried out among different researchers. They wanted to see why they wanted to publish. 1. Dissemination, 54% for first choice. Career prospect, if I publish it, I will get a job. If I publish this, I will get a promotion. Improved funding, publish in a specific area so that you get more funding. Ego, that fellow published in this, I want to do it in the same journal. Yeah, that's, well, these are the survey data, you know, it's not, it's been written. Patent protection, once you file the patent, yeah, you patent and then you try to publish the data from the patent, that is done. Yeah, to show that yes, you have the authority and to disseminate another way, and other choices are there. Somebody, my supervisor told me to publish it, that's why you are publishing it. Yeah. So, these are all the data from survey. Now, how do you prepare publication? I will go quickly on to these ones, these are quite straightforward. What definitely you can publish? Original and scientific result or methods. Yeah. Like you will see, if you open any journal, it says it should be original. Yeah. Original, that means it is not copied or it's just not thought of something. Yeah. Reviews or summaries of a particular subject, particularly synthetic, basically work that advances the knowledge and understanding in a certain scientific field, provides a valuable resource. One thing you would have seen, people, they have lot of review paper written up. Yeah. You see lot of reviews, and when somebody opens that review, they see like they never worked in that area. Yeah. I have seen sometimes a review paper coming in from a country on alcoholic beverages which does not consume alcohol. Alcohol is banned in the whole country. Yeah. So, if you are writing something, it has to be critical, it has to be this, otherwise it will be a collection of fact. Yeah. So, these are a number of different criteria. What not to be published? Report of little scientific interest, but or out of date work. Yeah. That means which is already been well established. If you start saying the sun rises in the east and sets in the west, yeah. So, that is what sort of stuff is there. Now, sometime it happens, we say, oh, this is already known and still paper is published, right, without reading the full paper. How many of you read full paper? No, abstract. That's easy, right? That's the reality. If you read the full paper, then you will understand what is there in it. Duplication or part duplication of previously published work. That's again. Preliminary result, yes, in some cases it is okay, but some cases it is not. Then you have to leave on the prerogative of editor to decide whether it is possible, is correct or not. Replication result, but in a different system. Yeah. Analysis of vitamin C using new HPLC equipment. Yeah. So, this type of work. Ask yourself, where could I best publish these results? Yeah. All these are questions which are part of this. I used to run as a part of as being an editor-in-chief of a journal, and then scientifically sound, scientific result, scientific narrative. Yeah. So, all these things what editor wants to see in a journal. Editor of a journal is not anybody's enemy, they take it as a newspaper. Yeah. What news should go in the first page, what news should go in second, third, fourth, fifth page, and what news should be there. Yeah. Is not anything is published, otherwise you have to publish apology. So, it has to be based on a fact. Yeah. So, the same thing works for journal. I will go to the important part of it. So, what different types of papers are there? Conference paper, you visited a conference, you write a conference narrative. Letter or short note, that means you discovered something and you want to communicate that one, that is rapid or short communication. Yeah. It is not that your research paper is, oh, it's having less data, let us put in a short communication. It is not that way. Yeah. Maximum word limit of any research paper is 5,000 word, yeah, including references and everything. So, 5,000 word is not big. We have one of the review paper which is only 1500 words review paper, that too with references. 1500 word is how much? 3 A4 sheets. One A4 sheet gets how many words? 450. Yeah, 400 to 450. That is the limit what you can type it on one A4 sheet. So, 1500 word. Journal name is Trends in Cancer Research. Yeah. So, it is only 1500 sufficient enough. It is not like making what you call same thing again and again. This sentence is good in this paper, copy and paste it. Same sentence, said same thing in another sentence. Yeah. It is something like I come from UP is in India, and India is a part of Asia. Asia is having this much of population, and Asia is in this, and you moved from one side to completely off tangent. Full original article and review papers. So, these two have the same value. It is not a short communication or a big communication. Yeah. So, next one. Now, this is a general structure of any research paper or any thesis or any report. Now, a lot of places, even in what you call in thesis in certain institution, what is done is the thesis is written as research papers published are added straight into the thesis. General conclusion, general introduction, and done. You do not have to write a classical thesis. So, what all is important? Title, authors, abstract, and all these things are important. Then IMRD, that is introduction, material method, result and discussion, and all those things are there in place. This is not only for this particular journal, but for any journal, because this is one of the publisher. You have Elsevier, you have Springer, you have different publishers, but pretty much this is same. So, how do you start writing the paper? How you write a paper? What is written first? Introduction or result or material method, or what is written first? Well, I have seen some people writing straight away with start with introduction. Yeah. So, always better to start from the center. Yeah. Whatever data you have, if you make a tables and figures of that particular data and write about that table and figure, what you have got, for example, never change your own style. Yeah. Make your own style of writing. I have number of researchers from different countries, different backgrounds. They all have their own writing style. What is important is take home message. Never to think that English is not that great, so I can't write a paper. No. If that was the case, then only England would have had the maximum number of papers. Yeah? It is not. Written English and spoken English, they are two different things. Yeah? Lot of people, same thing, written Hindi or write unspoken Hindi. Same thing, written Tamil and spoken Tamil, right? How many people can write correct Tamil or Hindi? We do all the mistakes. But when you speak, it's okay. When you talk in fluence, yeah, you would have seen the statement, how is things? Grammatically it's wrong, yeah. But when it goes in a flow, you don't notice it. The moment you go slow, you spot lot of errors there, yeah. So spoken and written is completely different, right? Anyway, so when you are writing, starting a paper, so these are pretty much standard, I am not going to go into these details. So if you have the data and you create a table or figure, write about that figure. This table shows this, x, y, z and all this thing. And then compare that particular data from the literature. Go for extension of writing. This is what you observed, what others observed, why your one is different and how it is different, what could be the possibility. Yeah. Once you write all the table and this one, then extra information, whatever is being done, can go back to your introduction as a part of literature review. Methods and material are already known. So you are, because when you start experiment, you have clear-cut methods and all. The problem starts when you start writing from the introduction, or worst case, start writing from abstract. Yeah. Abstract is written at the end. Yeah. So whenever we put a tent, we always put a tent from the center, right? Right? You know, if you go to camping and all, how do you start putting a tent? From the center and then you tie it around. So always start from the center and then take extra information here and an extra for discussion. So every element of the paper is completed. Then you have a critical analysis of your data. Otherwise it becomes difficult. You have introduction written and then your experiment goes in different direction. So write backwards. This is what it is, yeah. But at the same time you have your own way of doing it. Write figures and tables, your results, yeah, and then introduction and then you draw all these things. Then think about the title, but first time is we start thinking of the title. What will be good? Let's put this title, yeah. Sustainable approaches in this, yeah. You started the experiment of writing effect of heat on phenolic degradation and in conclusion you are writing this will solve the world's health problem, yeah. This is the biggest problem in summary and conclusion and as well as in abstract. Conclusion is on your data, on your study, not what will be the global one. If one or two such research can solve the global problem, 15 million papers which has been published even the last between 2013 and 2018 that have solved world's problem, right. So don't try to solve the world problem, just conclude what you have done it, yeah, right, or what could be the potential and what will be, yeah. So creating the niche area, what is already there. Sometimes the habit is there to hide the work, don't cite it, otherwise they will come to know, but you don't know how the system works, yeah. System is much more smarter. It creates a problem when we think we are smarter than the other person, yeah. So some guidelines for effective title. So what is there? The first thing is person starts reading a paper, oh, title talks about something and content is something else, yeah. Few possible words, avoid big complicated jargons, yeah. Adequate describe the content, should be informative and concise, identify main issues and finding, do not use technical jargons or unusual abbreviations, yeah. One of those video when we were having, it was abbreviation HMMA technique, yeah, high moisture meat analogues, right. No, HMMA technology. So, well, if you are writing somewhere, you create an abbreviation, leave it in the manuscript or title if it is there, development of high moisture meat analogues using extrusion. End of story. Yeah, effect of this, all this one. Just read through the title, you will see what is the title, what is the content. Then abstract. If you write at the end, it makes things easier. What is the objective of the study? What did you do? This was the main finding. End of story. When it says maximum 300, that is maximum 300. You don't have to write 298 word. Majority of the paper, the abstract is only 200 words or 150 words. Yeah. So this is another important section. This is all what you all know, because you write an abstract synopsis for thesis and masters. Yeah. So that is all becomes important. Core introduction, provide necessary background, put the study into the context. Suppose you are working on biodegradable polymer, you start writing plastic is creating so much of problem, plastic waste is this, all this data is available, you keep writing there. 1 or 2 introductory sentences, okay, then come straight to the matter. Yeah. Investigations are going on biodegradable polymer, and then work has been carried out in this. Your objective of your study is so and so. End of story. Yeah. Material and method, technique, and this is all, sometimes guidelines are given properly or given according, you have to use according to requirement. Should describe the main findings, figures and table, and your statistics as well. Yeah. Sometimes statistics are added in for the sake of looking fancy. You don't have to do that. Need based statistics, need based analysis of data is good enough. Yeah. Then discussion, sometimes these two part goes hand in hand. Yeah. Result is there, you discuss it, but some places you have to segregate it. So that's why to start from the center or backward is much better way of doing it. References, that's another aspect. So it's how many of you use EndNote or different types of tool to write references? Yeah. So EndNote is easier to see the correct referencing written in it, and then to use only the citation which are relevant to the paper. Sometimes you have to write your own citation because you don't want to describe the method again. Yeah. So just be careful how you use referencing, and is easier one is EndNote. You have a lot of different freeware software also to write references. Yeah. And it is not good to have mistakes in the references, because think the same, somebody citing your paper and wrongly written. Nowadays chances of having wrong references is bleak, just because nowadays those softwares are available which takes care of those reference formatting. Yeah. You can change the formatting in 1 click or 2 clicks. Yeah. So avoid excessive usage of reference. Sun rises in the east, there is no point in writing references. Yeah. Cheese can be produced from the milk, Tiwari 2023, that's wrong reference. Cheese was made somebody else. It's not that you reported in your previous paper, that's why you're putting in paper. That's wrong citation. Yeah. I've seen it. Yeah. And these are some of the things you should avoid. Then it will come automatically as a self citation. Yeah. So you will be caught at some point. So that development of the bad practices leads to a bigger mistakes. So EndNote, that's different versions are there, and there is a Mendeley, and a lot of different formats are there to use e-referencing. Acknowledgement, again that's obviously sometimes funding agency you have to acknowledge them, not like I thank my neighbor, my head of department X, Y, Z and all. That's, I don't know, it's I'm not here to comment on that one, but basically acknowledgement is only from where you got your samples. Yeah. From where was the source of funding, what was the conflict of interest, and all those elements related to that. Yeah. Now supplementary data, sometimes you load supplementary data based on experiment, and if you don't do it, that's fine, but you have to have those one. Remember, fair data management principle, findability, accessibility, interpretability and reproducibility or reusability. So this is very, very important to have all the data is there, and now this is all specific reference to a particular journal. Then comes, once paper is written, then comes the choice of a journal, where you should publish it. I know 99% choice goes with impact factor. But you have to see where your references are coming in from, where previous work has been there. Yeah, that should be the choice of the journal. There is no point in publishing animal feed related work into food chemistry, though food chemistry having a larger impact. Yeah, so that is not the case. And then where all is the journal peer reviewed? Then comes your question, journal impact factor, open access. This is now its new thing is coming up. Everything has to be open access, and sometimes the perception is, oh, you are paying it, so your paper is getting published. No, that's not true. All the Lancet work, Lancet is the premium journal, medical studies, they are open access. The choice here is the research which is based on taxpayers' money should be openly available for the public. Yeah, so that is one thing. That's it's not open access means people are getting published, because it is by law we have to make it open access. So institutions, they do have agreement with different agencies or different publisher that any paper goes in, it is having open access, so that it is freely available to everybody who is involved in science and technology. Yeah, aims and scope, nobody reads that. Saw the journal, nobody reads what is their aim and scope of the journal. And then author guidelines, intended audience in a mind, and then do not submit it to two journals and withdraw from the one whosoever gives you a comment. All the things are connected. Yeah, every journal is reviewed, every journal activities are watched by a certain agencies. Yeah, so never to do this mistake. Oh, let me submit one to food chemistry which is elsewhere, let me submit one to Journal of Food Processing Preservation or something, is a different publisher. No, I know a lot of people, they do it. The moment you click on their name, it will automatically reflect what is there. Yeah, so right audience, where do you read your papers or your research? Journals, peer suggests, or references published. That means peer suggests, that means your supervisor or your what you call it, guide or anybody is there. So remember, your supervisors are known as guide. Yeah, what does it mean? Who shows you the way. Yeah, is not the who will carry you to walk to that place. Yeah, so guide and supervisor, they are two different. Remember the word. Yeah, they can tell you where to see, not what to see. Yeah, so where your references are published. So all these ones are audience related. Then final check, avoid silly mistakes. Read through the paper, once it is finished, keep it and read it after 1 or 2 days. You will find your own mistakes. Yeah, so that you avoid unnecessary mistakes, so that you have scope is correct, requirements are there according to guide to authors, affiliations are correct, you have simple spell checker to check the basic errors. UK English or American English. Some places it is clearly written you need to have a American English. Yeah, or some place it is clearly written it is this one. If it is not written, use one format. Yeah, COLOR, COLOUR. Yeah, you know. So if you have one place you have color, you have another one is COLOUR. That's wrong. So you have to have a consistency. So I was in one of the PhD viva, I asked the guy that you have a color written in a different way in a thesis. Yeah, his response was, yeah, because I was dealing with 2 types of onion, white onion and red onion, but the question was related to this. Yeah, so consistency is important. This shows the person who is reviewing it how interested you were in doing the research work. Yeah. Then online submission system, I am not going to go into this. This is all there depending upon what journal is there and what is the publisher. So cover letter, is there sometime written? It depends upon what way you are writing, and it's already there is a template for that. So this is another one which goes along with the journal. So there is any question related to this so far? Pretty much is what already you know. Yeah, some form or the other. Now comes the review process. Yes, Mike, sorry. Conclusion is the main findings of the research work. Whatever research has been done, what is the main findings of the experimental results? Yeah, whatever results you have obtained, you have to just write about main conclusion of your research study. When it comes to abstract, that is abstracted form of whole paper, just like a synopsis. Yeah, so that means one or two sentences on introduction, followed by what method you used, what was the result, main results you obtained, and what is the main conclusion. Everything is abstracted. Yeah, that is in concise form. Writing whole of your review paper or research paper in 150 words. Yeah, that is what it means by abstract. That's the difference between abstract and a conclusion. Yeah, sometimes conclusion is written, this study highlights so and so and this. So they starting with the conclusion part of it. Whereas when you write an abstract, it says objective of the study was so and so. To address this objective, following protocols were established, or following protocol were followed, and we used these conditions, and this condition was found to be the best one compared to A, B or C. Yeah, this study highlights X, Y, Z, right. So the first sentence of each of those 5 sections becomes your abstract. Yeah, so that's abstract, means abstracted information. Sometimes it is known as summary. Yeah, summary of your work, or sometimes it's abstract. And then you have conclusion. Sometimes conclusion goes bigger one, in case of review paper, conclusion and future outlook. That's up to you, what way you want to craft it. Yeah. Now reviewing process, this is normal process. Paper submitted is desk rejected. Yeah. That does not mean the quality is not good. The thing is, it is out of scope, or they have published a lot recently in this area. Yeah. Other one sent to the reviewer, or further review needed, editor accepted, goes through this line. Yeah, or else revision required, revise it and go back. Sometimes you have, anyway, I will talk about that one again. Sometimes paper from here without going to editor goes straight to authors, because it does not fulfill the requirement of the journal. Yeah, or that is, there is a layer, when paper is submitted, it is handled by editorial assistants. They prepare everything, then it goes to the editor. From editor, he looks into it, then he sends to other editors. Then those editors can send it to other associate editors, and those associate editors can find reviewer, or sometimes EIC handles paper directly themselves. Yeah, that can be any of those elements. Yeah, and then it goes to review process. You get a revision, you modify it, then again goes back to the same reviewer or new reviewer. Yeah, it can happen. Yeah, so that's the way publication system works. So this is somewhat looks like a reviewing process. Yeah, oh, I submitted the paper. Same thing, you put yourself as a PhD thesis. Yeah, some people, they're ready to attack you. Why did you do this? How did you do this? Yeah, so this is all is the paper accepted or thesis granted. So this is the way most scientists regarded a new streamlined peer review process as quite an improvement. Right, means now things are becoming more and more open. Clearly you can see on a system what is happening. Reviewer comments are given, and it is also not required that you accept all the reviewers' comment. Either you respond or you rebut it. Yeah, when you rebut it and you put an email there with the proper fact, then paper can go back to revision. I have reverted so many times my decision. Yeah, because reviewer thought, a reviewer is thinking, no, that is not possible, other person comes back with the backup data, then decisions are reversed. So if you are not rebutting it, that means you yourself are not confident, you are chancing it. So that is important aspect. Now this is really important process. Quality, assessment of the importance of those findings, determines originality, can potentially detect plagiarism and the fraud. Yeah, a better system is not been identified yet. So whatever system we have, we are following that. We can always comment on a system. We all know that something goes wrong, everybody becomes intelligent. Yeah, so there is no robust system. Whether you talk even about any system, there are always loopholes are there, and system is continuously improving. Some journals clearly written who is going to review the paper. I've seen, we know the paper goes to a specific person and reviewer name is also written. This paper written by this person, reviewed by so and so, second revision by so and so. It is written there on the paper itself who were the reviewers. Yeah. So that's why if reviewer is reviewing it, sometimes their authenticity, their own reputation is at stake. If they just say, oh, that's fine, oh, he's my friend, I know him, let it go like this. Yeah. Then reviewer's credibility as a scientist is also goes in vain. Your teacher are teaching you subjects. If they give you an exam paper, you say, it's very good. He was very nice teacher, he told us all the questions. Yeah. Is good teacher for a short term. And other teacher, he didn't give you the question marks, he made you to learn, and he became a bad boy or a bad teacher in short term, but 20 years down the road, well, that teacher taught us properly. Yeah. So either you go for short term credit or you go for long term credit. Yeah. So that's why think on the reviewer side also. When it comes to the person, what you do when you write a paper, you suggest your friend or your friend's friends, somebody is there, so can you please look into my paper. Yeah. But again, that is not right thing. Yeah. So that's so what editor looks first and foremost, is paper suitable for journal, is research significant, is it is different to the prior work, that means what is already there, it is adding some extra knowledge to it, or is the same thing. Yeah. Does the paper adheres ethical guidelines? Ethical in the sense you do a sensory evaluation and you pick 10 people and feed them without following the approval process, then it is rejected. You would have seen all those COVID virus vaccine theories, you know, like how many people were given this drug and what was the size, only 500 people it was tested and implemented. So all those questions come into the picture. So how it is being chosen from the reviewers database, people who have published already, suggestions from the author, but in majority of the cases this is not considered. Some cases it is considered, some cases it is not considered. Suggestions from other reviewer for editorial board, editor's own knowledge. Yeah. So these are the way systems are selected. What happens now when a paper comes in, straight away system will say who is this author, what he has published, click on their name, it will say show what all they have published previously, how that paper is related to all other paper published recently, what are the potential reviewer for those ones, what are the matching work. So everything is there. So reviewer is not sending an email, click, 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 goes to them, everything is automated. Yeah. So it's very easy to find it out, and then again reviewer who reviewed it, oh, this person is reviewing for this author all the time. So reviewer is marked. Yeah. Marked with a small asterisk on the system. Be careful with the submission from this author, and that is on all the system, like putting it in red corner notice. Yeah. And then whatever you do, everything is looked into with magnifying glass. So even you have best work also, after 5 years it will have an impact on that particular process. Yeah. So reviewers, manuscript within the scope of the journal, sufficient quality, what you have done, whether research, analysis and your conclusion valid, that is very important. Yeah. Is presentation of figures table correct, aims and achievement. Yeah. Majority of the cases it is only reviewed what is presented. Yeah. Or if you have used old technique, whereas new technique is available, those things are commented, existing literature cited appropriately, statistics, areas for improvement and ethical statements. So this is all what a reviewer looks for. Possible editorial outcome, desk rejection, reject, revise, accept. Yeah, that all whosoever has submitted the paper, you are aware of that fact. Reason for major revisions, faulty methodology, inadequate references, poor quality supporting figures outside the scope of the journal. Majority one is poor writing style and use of language. Yeah, that is one of the reason of writing a wrong sentences, or which makes meaning which dilutes the meaning of the data what is there. Yeah. This is higher, A treatment was higher compared to B, but it was statistically insignificant. What does it mean? Yeah. Either it is higher, it is a lower. Statistic, you talk based on statistics. Yeah. Now again, subject of little novel interest, not generally available, poorly written discussion. So you can see majority of this one is your this, other one is 16, novelty and all those one. Yeah. Novelty does not mean that you have to use a new technology. No. Novelty means either in approach, same conventional extraction processes, ingredient dried, extracted, same ingredient fresh and dried, and to see the comparative one, you are changing some method to see whether you need 1:20 solvent in dried one. In a fresh one, you need only 1:5. So using reduced amount of water, yield differences and quality, that is also novelty. Yeah. Novelty does not mean that you need to use new technologies. Yeah. Novelty is in the approach itself. Yeah. And what benefit it will add. So those all things comes into novelty. So what happens when paper is rejected? Some people, they get depressed, yeah, or give out to editor. Yeah. You ain't gonna say, this is useless system, publications are waste and all those. This is common thing. Yeah. Considering changing the job, I can't publish is better, I should be working in industry. Yeah. Reviewing manuscript and deciding the reviewer had a point. Yeah. So best one is last one, right? And also seen the revenge. Yeah. If your paper is rejected, if I send the paper to that person to review it, definitely he will be bananas on that paper. He will go just, my one was rejected from the same journal, and he'll just be very fierce. They use sometimes very, very derogatory languages. So those comments are edited, or we just mark those type of reviewers. So you have to be careful what you write it. Yeah. Never to take a decision when you are extremely happy or you are extremely angry. Both the decisions are wrong decisions. Yeah. When you are very happy, you decide something which end you up in a problem. Yeah. Sometimes you are very angry, you take a decision that also puts you in a trouble. So once paper is rejected, leave it and come back and see what is the comment there. And sometimes paper is rejected without looking at the reviewer's comment, next paper is submitted to another journal within half an hour. Yeah. And it goes to the same reviewer. Same story happens. Then you say, oh, I submitted to 5 journals, all 5 journals rejected it. Yeah. But you did not sort out the problem. Yeah. All along was cleaning the mirror, but dust was on my own face. Yeah. Remember that phrase, so that's why you have to do this. We all pass through that phase. My skin is very thick. A lot of people, they come up with lot of different types of, oh, you rejected all the paper coming from A, B or C. That's not the case. 90% of the cases don't see who is there on the, who has written the paper. Yeah. He just comes in straight away to see the abstract and read the conclusion, that speaks everything. Yeah. You put lot of effort in abstract and conclusion is something else. So it's always I consider this is the best model to go with the frustum. Yeah. That means this is the work what you have carried out. Your literature review is related to this. This is your introduction and this is your title. Yeah. And all the discussions are pertinent to the work what you have carried out and your conclusion related to this. Otherwise what happens, you start paper with this way, this was your introduction, method was here and your conclusion is in about something else. If you remember that cockroach story, or if you remember 3 insects story, yeah, this happens. Read any sometime paper, your work was effect of temperature or protein coagulation, and at the bottom you are writing the temperature is important element which can kill the bacteria. Yeah, you know. So that it has to be a straight line like a full story. How do you feel? You go and watch a movie, title is something else, movie starts with discovering of a person and end up in a person becoming a millionaire. Yeah. Would you like that movie? No. So that's why it is very important, the conclusion, the end climax should be within the context of the movie, yeah, right? So that is why same thing applies here. So because these are just like a magazines, you know, take it in that way, is a scientific technical magazines. So if you'll see this one here, I just mark the person, I authenticate, yeah. The software system is very, very robust. They know everything from where, what sentence is coming from where, crawled on the day, and from where it is coming in. You know, all those things are, it is embedded into the system, yeah. It is already embedded in a system where all things has been taken. So see almost 70, and this is excluding biography. So what did you write there? Yeah. Well, this is a worst case scenario. So everything, whatever has been copied, and it can easily found out that whether it was your own part or it was somebody else's part. Yeah. So this is very important. Software straight away checks it. The obvious question comes in, what is the level of plagiarism allowed? Yeah. So if you are right, well, yeah, 20-25% can be depending upon where it is going in. If your results are coming in from there, then it's a problem. If coming in from the method, that is understandable. Sometimes your own name comes in as a 0.1, 0.5% because you have published previously, that is also picked by a system. So this system is used with a pinch of salt. Yeah. Sometimes you have a thesis which is electronically available, you write a paper from there and everything is 100% copied. Yeah. So that's, these things do happen, and then you have to cite it, this is coming out of a PhD work or presented at a conference or so. Yeah. So that is all. Even sometime it is run, and if suppose it's coming, your own name is coming there, if it is in other public domain, that's different story. So it has to be used with bit of caution. Yeah. I just wanted to put a worst case example. Sometimes you will not know why your paper is rejected first place. This could be one thing, and sometimes it is written the plagiarism 35%, 45%. Yeah. Then response goes from here, oh, all the references would have been there. No, it is, see, excluding biography. There is no references. With references would have, it was 94 or 95%. Yeah. So what did you add there? Taken 5-6 papers, taken, oh, they also used the response surface methodology. They took all the resulted discussion on their part, changed the sample. Yeah. Rest all remains the same. So that becomes important part of it. Now once it is rejected, that's not the end of the word. Rejected, one should not take it personally. Yeah. This fellow is this, he hates this institution, he hates this country, he hates this one. No, nobody hates anybody. Yeah. So try understand why paper was rejected, benefit from editors and reviewers' comment, and take advice seriously, re-evaluate it or resubmit it to the same journal and highlighting the changes. Yeah. Or if they are suggesting to go for another journal, go for that one. Yeah. Because there is also self transfer is there from one journal to another one, right. So you should be like this. So submitting a revision, again you just take point by point. If you have a major revision or so, don't think if you have minor revision, just don't do any change and submit it. I have seen papers rejected after R4, even after minor revision it's gone to major and major then rejected. It happens. Yeah. Because you did not address the reviewer's comment. Yeah. Okay, so that's so this is all. It is nothing personal between editor and reviewer. They are just trying to help to get best research published. Yeah. So what happens after acceptance? You all know. You all go to the party. Yeah. So stand out of the crowd. Be cool. Any questions so far related to publication? Yeah. Yes, sir.
Sir, how to write discussions if the work is not done before?
That's very, very valid question because there is always something there. Can you give an example?
So like I'm just giving some treatments on isolating protein in particular plant-based legume. So they have isolated protein from legume, but no one have given the treatment, related treatment, So how to interpret the results while writing discussion?
Okay. So, your main purpose, their objective was to modify the plant protein by using a technology,
Yes, sir.
yeah, and that technology has not been reported before, right. So, why did he use that technology? Because other technology, it was modified, these were the issues, and by using this particular technology, you are changing those issues. That is the way discussion has to be written. Then only the novelty is there, yeah. So, that means you just say what are the properties required. Currently X, Y and Z use this method, and these were the amino acid profile of the product, or this was the digestibility of it. However, using this technology which works on this principle, make these improvement, yeah. Hence this technology is much better compared to other one, yeah. That is discussion does not mean if it has been previously done, then you question the novelty itself, yeah. Any other?
Sir, what is the difference between NOS rating and impact factor?
Which one, sorry?
NOS rating and impact
Okay.
factor.
Yeah, this is NAAS, National Academy of Agricultural Sciences, yeah. That is a national body which ranks different journals, yeah. That is a national body in India which ranks different journals, and that is directly proportional to the impact factor of the journal. If you see the rating of the NAS rating, and if you see those journals along with the Science Citation Index journal, you will see you can draw the straight correlationship between both impact factor and those rating. At the same time, certain journals are also included in NAS rating which are not there in Science Citation Index, yeah. So, that is what it meant. You have to see the journals which are having Science Citation indexed. That means those journals which are indexed in that category. That does not mean it has to be international one or it has to be national one. Like if the journal you are publishing it, if it is not having NAAS rating, that means that journal is no value, yeah. And almost all whatever having an impact factor, they all are there in NAS rating. Sometime it takes time for other system to adopt that journal, yeah. So, that is both, because critical reviews and all those journals which are having higher NAS rating, the same rating is there for impact factor of those journals.
Sir, I submit one paper on engineering properties of osmotic dehydrated paneer, sir. After reviewing, the reviewer said, I compared my product osmotic dehydrated paneer with some seeds and dehydrated product, not dairy product. They said compare with the related dairy products, sir, but not dairy product, engineering properties of dairy product not existing research. So, what I discussed.
So, you just have to write a rebuttal there, because no such work has been there, yeah. But before you respond to that, check it if it is there or not, yeah. So, just you have to just write a rebuttal. Prior work or related to osmotic dehydration of dairy product is not available, yeah. But when it comes to this one, osmotic dehydration, your purpose is this one, but salting of cheese is there actually, you know, like what you do dry salting of meat, same way dry salting of cheese, of mozzarella and different types of cheeses.
Yes, sir, but I am do osmotic dehydrated. Moisture
part.
content is very low, but cheese moisture content this is differ from.
Exactly. So, that is why you just have to respond to give a rebuttal to that one is not available, yeah. So, that is why it's one way is right, you cannot compare apples with mangoes, yeah. But if it is not there, you have to compare the relative field. If it is not there, you have to just eliminate it.
So, the paper with more than 3 authors has more credibility in research work, or else even one person as an author has more credibility in that research?
Well, that's not that's nothing to do with the credibility. It depends upon the type of the work, yeah. I have one paper which is having 36 authors, yeah. That was guidelines to report non-thermal technologies, yeah. There are 36 authors. Take any physics paper, there are more than 100 authors papers are also there, yeah. Whereas all the authors, they should have some technical input into it, yeah. So, that is the way to explain. Yeah, if you are having a paper name added in without any contribution, that is different story. Yeah. So that is all to do with what is the content inside. If you are collecting, for example, data of milk produced in across state, and everybody is doing it from each and every state, they collected data, then it will be multiple author paper. Yeah. So that's all to do with what is their content. There is nothing, credibility is on the research work, not on number of authors. Yeah. And that's why suppose you are just doing temperature effect on milk coagulation and you have 20 authors in it. What was their contribution? There it lacks. The first one is obviously the person who writes it or who has carried out the major part of work. Rest all list is decided. The last one is the person who is the principal investigator or the corresponding one. So these orders are defined based on every institution, policies are different. Yeah.
So what if the paper is rejected without any reason, like without any comments on first?
So that is desk rejection, either based on a novelty or doesn't fit into the aim or may have high level of plagiarism. Yeah. Normally it's not happening nowadays, like all the explanations are given. Paper is rejected because of out of scope. That's one of the major one. Because see, remember in a year or in a year nearly about total rejection from submission to the final one, in some cases 80 to 90% papers are rejected. Yeah. Because journal can publish maximum of 300 or 400 papers in a year, and this much number of paper comes almost every week or every month. Yeah. So there is also a pressure what goes in, what should not go in. Yeah. Because journal itself has to maintain its own reputation, has to maintain its own readership. So these are the criteria which leads. Mainly outer scope one comes in first. Yeah. If it is rejected from the desk.
So can we file the patent after publishing a paper, or which is the right time?
No, it's basically one it is published, that is it is in a public domain, and you transfer the copyright to the publishers. Yeah. So the IP is secured first, and then it is then it has to be discussed according to the policy, then only it goes for publication or so. Because if it goes in a public knowledge, then there is no longer novelty. Okay, so this concludes your publication one. Now we'll go through last part of this. Yeah, you don't have any question related to the survey question. How many of you filled in the survey questions, and who did not fill in? Do you want to see the result? Yeah. So, first question, how did we envisage the blue circular economy reshaping marine industry over the next decade? Yeah. By increasing efficiency of marine resources and minimization of waste. Yeah. Right. That's the major answer, first one. And then again others one there. That's good. By reducing pressure marine ecosystem through sustainable practices. Second question. In your opinion, what are the most promising application of marine resources in a circular economy model? All of the above. Yeah? Where is it gone? Sorry. Second decade. Yeah. So, all of the above. And then, do you think public awareness about about the blue circular bioeconomy is sufficient? How can it be improved? So, mixed answers. Yeah. That is expected. We all come from different domain. Awareness is sufficient. I would like to know who are those where awareness is sufficient. More educational campaign, same. Yeah. Awareness is growing, but outreach to policymaker business is lacking. Awareness is limited, and target media coverage could help. What innovative technology or practices could have the greatest impact on achieving zero waste fisheries and aquaculture? All of the above. Yeah, that makes sense. That means all the technologies. Now it says what the best answers goes on the top. That means advanced waste recovery, AI driven closed loop water recycling system for farm. Yeah. So that means I can say that some bit of understanding is there of whatever was covered for 8 or 9. whole of this GIAN program. How viable do you think algae and seaweed are an alternative material for biofuel and bioplastic on a large scale? 50% they do agree, that's good. Yeah, it cannot be, everybody cannot agree with that, depending upon thing. Moderately viable, unsure, not very viable, cost effective market. I would like to see who is that respondent for this. I can guess who is the respondent for this. It was me. When I created it, I responded all the wrong ones there, which is not correct. Yeah. So I'm really happy to see this answer, that what you already have it here, right? Yeah. So that's nice part to see all this answer. Yeah. Then what challenges need to be addressed to ensure that marine biomass production doesn't inadequately harm aquatic ecosystem? Develop sustainable farming model, that is production, that's good. Ongoing research to monitor ecological impact and strict environmental regulation. These were the individual answers and you answered all of the above. Yeah. So that is again good thing. What role should government play in accelerating the adoption of blue circular economy? Is establish clear regulatory framework. Perfect. Incentivize private sector investing through subsidies. Yeah. Correct. Providing funding for research and development. So that means all are above 71%. That's, I like this answer. Yeah. We can do through all the ways. How can international cooperation be strengthened to address policy, regulatory barriers for circular marine industry? All of the above. Cross-border collaboration, which is happening. Hosting global forum for shared best practices. That's why we need open access research. All the publications should be, which is carried out based on publicly funded research, should be in open access. For open access, it has to be paid either by government or by some agency. Yeah. Then creating unified international standard for marine resources. Nobody accepted that, that's correct, but all of the above, that is very, very important, because ocean is what is linked, is connected. There is no ocean is in isolation. So bioplastic problem is a global problem. Microplastic problem is a global problem. Yeah. What incentives could encourage businesses to invest in circular processes? Consumer demand for eco-friendly products, access to government grants and funding, tax break for sustainable business practices. Yeah. So these are the things, some of the things are happening at government level. Those who are involving environmental credentials to their businesses, they are getting rebates on taxes. The money invested in research and development, every €1 invested in a research, they get 20% discount on their taxation. So these are the incentives are happening. Do you believe the blue circular bioeconomy can provide significant economic opportunities for coastal communities? Why or why not? Yes, it offers opportunities, possibility, but proper training and resources. So completely agree. Yeah, those two responses. Unsure, no economic benefit, may be limited to large scale enterprises. Yeah. So are you all happy with your responses? Yeah. How can a small scale fisher or aquaculture operator be included in transition to circular economy? By offering training programs, by providing financial and technical support, by involving them in policy making and planning processes. Yeah. So this one is basically a last point is a co-creation. Yeah. Right. When you involve them in making plans and policies, that's a perfect stuff. What strategies would you recommend to balance economic viability, sustainability in marine resource industry? Eco-friendly technology, promoting public-private partnership, establishing certification for sustainable product to increase market value. Now we have organic label, organically produced. Now slowly carbon footprint will come in, because when you book a flight you save this much amount of CO2. Yeah, carbon tax will be coming in. Then again the mark may come up with sustainably produced, or like a halal certification, all those things are coming on a product. Same as sustainability mark will be coming in near future. What ethical concern might arise from large scale adoption of marine based ecosystem bioeconomy? overexploitation, unintended harm to biodiversity and ecosystem, displacement of small scale fishermen. Yeah, it's all of the above. Here again respondent was me. Yeah, so that's good. So I was expecting to have responses in all of the above or 3, not the last one. Yeah, and last one was responded. I did respond to that one because I was just checking the questions, how it is working. Yeah. Now, how do you think consumer behavior will need to change to support blue circular economy? Reducing reliance on single-use plastics, increasing demand for sustainable and eco-friendly products, willingness to pay premium prices for sustainability. Yeah, all of the above. Yeah, so that's perfectly perfect. Now, next, in your opinion, is there a risk of over relying on marine resources for circular processes? How can this be avoided? Possibly, but risk can be mitigated through technological innovation. Yes, through a strict resource management limit on extraction. Yeah, no marine resources are abundant and can sustainably be managed. As of today, yes, but in future we don't know. Yeah, so that's why the responses are pretty much 90% and above this one. Now, what would a fully realized blue circular economy looks like to you in terms of environment, economic and social outcomes? Minimal waste, equitable benefit, all of the above 66%. Yeah. How can we measure the success of initiatives aimed at promoting the blue circular economy? By tackling reduction in marine resource waste, correct. By monitoring improvement in ecosystem health, through economic growth and sustainable industry, all of the above 77%. What role could you or your community play in advancing the principles of blue circular economy? All of the above. Educate others, advocating for policy that prioritizes sustainability, supporting local initiative for sustainable marine resource use. What should be the future priority? This was very, very tricky question. There was no all of the above or. So, you 46% they think what should be a future priority to reduce waste or valorize, to reduce or valorize side stream, 46%, that's good. So, you stop wasting food now from now onwards. New food and feed product 26%, agreed. Alternative packaging material 15.4, future protein 11.5, those who are working on alternative protein definitely. Yeah. So, technically if there was another one all of the above, that would have scored the most. Yeah. I just wanted to see what are your priority area. Yeah. So, with this oh sorry, last question. How can we achieve net zero carbon economy? Unlocking the potential of seas and ocean, using better what we already use, changing consumer diet. This was a bit surprising, none of the above. Using better what we already use, so the contradictory answer from the previous question. This, by the time you reach to this question, there might be a fatigue. Need to finish it. Without reading it, tick the boxes. Yeah. Because the previous question and this question, yeah. So, unlocking the potential, using better what we already use, that means reducing the waste. Yeah. This question and this question contradicts. Yeah. So, any other opinion or so? So, with this I can say that at least some message has gone across. Yeah. Any question? So, with this we close this session and any announcement? We are going to come back in again at around 4 o'clock.
honorable dignitaries on the dais, respected faculties, participants, and my dear friends. Good evening to one and all present here. And on behalf of the organizing committee, I welcome you all to the valedictory session of the GIAN course on Sustainable Blue Circular Economy of Food and Feed Value Chain, sponsored by Ministry of Education, Government of India. I would like to thank you all for joining us for the last 10 days. Let's start our valedictory function. First, I would like to invite Dr. Madhuresh Dwivedi, sir, the coordinator of the GIAN course, to deliver his welcome address. Please, sir.
Good evening, everybody. Respected Head of Department, Professor Sabyasachi Mishra, sir. Professor Chandra Pradhan, sir. Coordinator of the course and Associate Dean PGNR NIT Rourkela. And our esteemed foreign expert, Professor Brijesh Tiwari, all the way from TEAGASC, Ireland. First and foremost, I would like to welcome to you all to this particular event of valedictory session, as we have already met, but this session holds a very special for each one of us. Why? Because that we have now sustained this sustainable blue circular bioeconomy course for this last 10 days. And I hope this 10 days would have been given you some insight in food and feed value chain, including this blue circular bioeconomy. I would like to welcome all the participants, those who joined us from the different parts of country, all the participants, 30 participants, those who came. I would like to just tell you the stat, or to all the participants, that we have received more than 280 registrations, not only from India, but we have received it from Vietnam, Thailand, Pakistan. All these countries were there. They have shown interest to join us, but because of the lack of seats and the availability, we had restricted only, and we have selected only you 30 guys. So I just expect that this course, to all the 30 participants, those who have joined from the outside of the NIT Rourkela, this course would have been given a special insight about this particular course. I would like to thank and welcome each and everyone, all the faculty members and my research scholars, those who have been the key persons, those who have actually delivered and made this program happen. Sometimes I may not be available, but all the volunteers or the students, coordinators, those who were there, they were always there for you, and they always wanted to help you. With that, I just wanted to welcome all my volunteers and my students. I would like to welcome the staff and the professors from the different universities. It gives us the immense pleasure to host you all and give this particular knowledge on the basis of foreign expert. What is the basic aim of this GIAN course is to get the acquaintance with the recent advancement which is happening not only in India, but it will be developing in India, that can be coming, or that will be coming from where, that we have to think of. So with that stat only, we thought of this blue circular bioeconomy, because bioeconomy, always when we are hearing, only 2-3 things we were knowing, that spirulina is there, or say some algal things are there, but now the horizon has been different altogether. With this horizon change and the knowledge of this, we have the best expert with us, that is Professor Brijesh Kumar Tiwari, from Principal Research Officer of TEAGASC. And once I attended many of the lectures here, and I came to know that the fundamentals, the things, the advancement, the innovative approaches which has been taking place in this particular domain was really an eye-opener and an icebreaker for us at Department of Food Process Engineering, NIT Rourkela. Because once we are thinking about this, any innovative approaches, we are lagging behind that how we can just intervene not only the science which is behind, but in relating the science with the engineering. With that thing only, the lecture number 17 of Professor Brijesh Kumar Tiwari
he has demonstrated like the cold plasma techniques and everything, and he related with these things with the application. So those things actually gave us the, like, we also get the ideas to know from a better expert. So I would like to welcome Professor Brijesh Kumar Tiwari again and each one of you to this particular valedictory session, and I hope, if not completely, we are up to the mark in providing you all the facilities, but I hope this program, definitely it has been delivered to you as a best, with the best expert, and he might be very much successful in receiving this, because as we are seeing the all the feedbacks and everything, and we found out that at least this course has been understood by many of you. So that is our target, that is our success, and that is all because of you guys. So welcome once again to this particular valedictory section, and I will request to proceed further. So thank you so much for joining.
Thank you, sir. We extend our heartfelt gratitude to our esteemed chief guest and the speaker for the last 10 days, Professor Brijesh Tiwari, sir, Principal Research Officer, TEAGASC, Ireland, for traveling all the way to NIT Rourkela and sharing his valuable knowledge with us for over the last 10 days. Your thoughts have truly encouraged and inspired us for future endeavors. I would like to request you to share your experience with us, sir, please.
So, thanks very much. Thanks for the introduction. And first of all, it's always been a pleasure to be in NIT Rourkela. I know it's easier to come till Delhi and then you have to follow all the route from Ranchi and different places. And to be honest, this is really a great campus with great professors, as well as all the hospitality what I have received, and even all the volunteers who've been working tirelessly and fulfilling all the requirements, whether it's for you guys and as well as all the professors. And it was really a pleasure to be involved in these type of programs where you can share experiences and to see what best can come out of it. And to be honest, if the way this morning we were discussing about how much money goes in to create a knowledge. Government is investing huge amount of money creating such type of programs, and all the professors over here, they have their own regular project, regular teaching commitment, and they're developing these type of programs. So I must say that it was really interesting the last 10 days for this particular program, and I hope you would have learned something. And if you have any questions related to that, and if you want to contact further, you have all my contact details. So feel free to contact, and just remember one thing, not to drive away what you see. Whatever you do, try to be innovative in that particular area. Because if you go to a conference, you see some idea, start working on it. Then as you go as you proceed further, then you realize, oh, this is not good, let me try other one, right? So try to not to chase the money, that means chasing the new area. Just make your own area so attractive that people will come to that particular area. It is not that microalgae research is there, everybody should go and work in that particular area, or biodegradable packaging material. But whatever area you work in, just try to be more innovative and think about it. Observation is the critical part of everything. Yeah. So that is one thing important, and try to do something rather than becoming something. If you try to do something, you definitely become something. If you want to become a best food engineer, you cannot become just like that. If you do something related to that, you will automatically become. So with this, I don't want to take too much of time. You have already heard me a lot for last 10 days. You might be sick of the voice. So I'll leave it on, and I must thank all the people behind the stage, as well as Madhuresh for inviting me over here. It was nice to be in Rourkela, and also head of department and associate dean, just to be here and during the holiday season. And where you all know this is the time where most of the people are on leave, and they spend their time, as well as the person who has been operating the camera and recording, and all these guys, they spend a lot of their time in making this program successful. I hope you would have enjoyed last 10 days, and with this I conclude the session, and I'll be leaving shortly. And then if you have any questions, feel free to be in touch. Thank you.
Thank you, sir, for your words. We would greatly appreciate for your feedback on the program to help us improve in the future program. Your insights are valuable to us. I welcome you participate onto the stage for your feedback. Please.
Good evening, everyone. On behalf of every participants, I would like to thank all coordinators and students coordinators for organizing this 10 days GIAN course. And a special thanks to Professor Brijesh K Tiwari sir for giving us an explanatory explanation on biocircular economy and from the basic concepts to the present technology, and it is very informative, sir, and also it is very useful for me as I'm doing my research in the ultrasound, and also I came across his research papers and all, and at last I would like to thank all for the delicious food and the safest accommodation. Thank you.
Thanks for your feedback. Does anyone else have something to add on? I welcome one more participant for your feedback.
One PhD, one master's and one BTech. Come fast. Masters. Who are from masters? Okay, PhD. You will be next.
Good evening, all of you. As she already said everything, not I can't add much more words. And thanks to Brijesh sir and Madhuresh sir, and to all our PhD scholars, especially Ganga Bhaiya, Shubhit Bhaiya and Kishan Bhaiya, and all the PhD scholars for helping us and understanding us all the things, and always available for us. Thank you.
Good evening, everyone. I want to special thanks to Madhuresh Dwivedi sir for choosing us to in 30 candidates for this training program, and special thanks for also Brijesh Tiwari sir for teaching us in about blue circular economy, and in that our basic concepts are very clear. We are much more know about in seafood and about blue circular bioeconomy, and also thanks for Ganga sir, Subhit sir and Kishan sir for their support in our hostel and their accommodation system and their support in food also. Thank you, sir.
आदरणीय यहाँ पे बैठे सभी आदरणीय गुरुजन एवं चगास से आए विशिष्ट गुरुवर डॉक्टर ब्रिजेश तिवारी सर, यहाँ बैठे मेरे तमाम भाइयों एवं बहनों, इस संध्या वेला में हम इस साल के अंत के सबसे सुंदर अध्याय का अंत कर रहे हैं, और यह जान के हमें खुशी होगी कि हम इस नए जोश के साथ इसको अपने सर्कुलर ब्लू इकोनॉमी में हमेशा ये चलाते रहेंगे अपने नवोन्मेष से। और इसी के साथ हम अपने सभी तरफ से एक छोटा सा मिलेट बास्केट मैं अपने सबके तरफ से मैं उनको देना चाहूँगा। धन्यवाद।
Thank you, participants, for your feedback. Now, I would like to request Professor Sabyasachi Mishra, Head of Department of Food Process Engineering, NIT Rourkela, to address the gathering. Over to you, sir.
Good afternoon, everyone. This is really a good opportunity to see all of you happy and knowing that you have such good feedback about the program. It's indeed a long program, 10 days almost. Normally the GIAN courses are for 5 to 6 days, but 10 days program, and I could sense it in the department in all labs whenever I visited. The way you have enjoyed all the experiments and demonstration, I probably think will carry over for future also. We'll have proper interaction in future also, and the opportunity that has been given by the ministry through GIAN to learn something through a foreign expert, I think that is fruitful today. And Super 30, you are 30 numbers, right? So I just remembered that Super 30. So you are always welcome to our department anytime in future. This is a opportunity like to develop interaction with each other, and anything that you need from the department, I am always there. My coordinators are there. Professor Tiwari is always there. Probably what I have thought of proposing Professor Tiwari as an adjunct professor for our department, and hopefully we will have him here. And I wish you all the best, and in advance Happy New Year. Thank you.
Thank you, sir. Now, I would like to request Dr. Brijesh sir to give away the certificate over to participants. I will call the names. Please come one by one to receive your certificates. Someone help. First participant, Giri Sachin Arun. Dukare Amol Prakash Rao. Shreyash Gajendra Nandeshwar. Divyanshu Kashyap. Sir, I am inviting them for giving the certificate for the student organizers. Jyoti. Ritu Kumari. Jagan Mohan Kumar. K. Kamalishwari. K. S. Kavya. S. Dinaha. E. Ramesh Khanna. S. Vignesh. M. Tamilarisi. D. Bhagilakshmi. M. Azrun Fahmita. S. Madesh. S. Bharanidharan. Anthony Sunny. PM Dice Marshall. Lijoy George. M. Gokulnath. T. Nandakumar. This will be given by Pradhan sir and this will be given by Mr. Okay. Mishra sir, Pradhan sir. I'll just change this to Mishra sir. S. Shivaratnam. R. Chandru. D. Aravind. Bharadraj. Gohul M. Das. N.B. Nishant. K.S. Naveen Venkatesh. Abhishek Gaurav. R. Santosh. Salman Hashmi. Thank you, sir. Now I would like to invite Professor Sabyasachi Mishra, sir, to give away the certificates as a token of appreciation to the student coordinators of GIAN course. Student organizers, Chingakam Natomba Singh. Subit C. S. Ganga Kishore. Kishan Kishore Gupta. Firdosh Nesha. Rakshit Patel. Thank you, sir. I would now like... I invite Seema to receive the certificate, please. Thank you, sir. I would now like to invite Professor Chandra Pradhan, sir, to give away the token of appreciation to the students who helped in the demonstration and the smooth functioning of the GIAN course. Shibashis Sahu. Jishira Chetia. Garimalla Jawaharlal Nehru. Thank you, sir. I now request Rajesh Bevria. Thank you, sir. I now request Professor Sabyasachi Mishra, sir, to kindly present a token of appreciation to our esteemed GIAN course instructor, Dr. Brijesh Kumar Tiwari, sir. Thank you, dignitaries. Now I request Professor Ramachandra Pradhan, sir, Professor NIT Rourkela, and the coordinator of this course to propose vote of thanks. Over to you, sir.
Thank you. Respected dignitary on the dais, and my dear student, A very good evening to all of you. So it is the validated section, and I thank you all of you for attending this 10 days GIAN program. So I hope you learn many things on this GIAN courses since last 9 or 10 days, including all this innovative approach, the sustainability, the blue circular economy, the food, feed, everything that I hope Professor Brijesh Tiwari, who has a vast knowledge on this thing, he has explained, and as per your feedback, we got to know that everything that you are happy, and will be that whatever that you learn, that will be helpful for your further research or further study. So with this, I must thank you, Professor Brijesh Tiwari, who came along from the Ireland, and who is always with us, who is supporting us at every time, including this GIAN course, including workshop, conference, every time, whatever we want, he always support us. Thank you so much, sir, for your always behind us with Department of Food Process Engineering, including us. And thank you for your energetic talk. And though I am not here, but I came to know that whatever the lab facilities are there, whatever lab that you have done, whatever the theory that you have done, everything gone on smoothly. And thank you so much, sir, again for nicely conducting everything from last 9 days. So thank you so much, sir, and we looking forward for your continuous support for the overall development of our department. Thank you so much, sir. And I also thank you, Professor Sabyasachi Mishra, who is the head of the department, and always encourage us, always encourage all the faculties, always encourage all the students and other staff to do such type of courses, workshop, including all teaching and practical everything. With his support, our department is going high, and we hope that with this support, our department will be a big name in coming future with the United Rourkela brand. Thank you so much, sir, for your presence in this validated section of the GIAN. I must thank you, Professor Madhuresh, who is the main coordinator, or who has done everything behind the screen or in the front of the screen. Okay, whatever that from course outlet to this, from today or tomorrow session, whatever he has a plan, that everything gone smoothly, and it is his painless effect, or it is his team effects, or it is his enthusiasm, you can say, that we conducted this GIAN course since December 20. And thank you, Professor Madhuresh, and we continuously looking from you from this type of course in the department. Thank you, Professor Madhuresh. And I also thank to our GIAN coordinator, the IIT Hyderabad and the Ministry of Education, who has supported financially and other support for this conduction of this GIAN course. With the help of the MOE and help of the IIT Hyderabad, we conducted this GIAN course. Thank you, IIT Hyderabad, and thank you, Ministry of Education. I must thank to our administration, NIT Rourkela, and other staff, employee who has directly and indirectly involved to conduct this GIAN course. I must thanks to the Mr. Pati, who is just doing the live recording and all these beautiful things, and his team, of course, his team. Always his support is there since last 9 days or 8 days. He is there in this hall and doing all type of recording, and it's a, I can say, YouTube live is going on. Thank you, Mr. Pati Babu, and all this team. Thank you, and thank you the Untitled head for this facility of this PPA. I must thank you all the participants that who are came from all the parts of the country. With your energy, with your support, with your involvement, with your you can say cooperation, we are finally finishing these courses. Thank you all, and I hope you learn many things, and keep in touch with our department. You meet our department faculties, you meet other professors. Those maybe who are not available here, maybe you can meet in the department. The all professors here are very supportive and very helpful. So everybody, thank you for joining this GIAN course from December 20 to 29. And I hope that you have enjoyed the NIT Rourkela campus, you have enjoyed the Rourkela, you have enjoyed the department facility, and you have enjoyed Professor Brijesh Tiwari lecture. And with this type of help, with this type of cooperation from you, we successfully conducted. Thank you all for this attending this session and attending this GIAN course, and I wish all the best for your future. I must thank all the volunteers, including the student demonstrator and other volunteer who has actively involved since December 20 or before that. Okay, because with the help of them only, we are conducting, or we have concluded this GIAN course. Thank you all the volunteers, okay, and the team Madhuresh, you can say. And also I thanks Mr. Rajesh, who has taken care of all the hospitality of our guest, Professor Brijesh Mishra. Thank you, Rajesh, for all your help. Always you are there to help us for your all these transportation facility, or hospitality facility, guest house facility, or fooding, lodging, everything. Thank you, Mr. Rajesh, for your support, and you are here to celebrate this the validatory section of the GIAN from 20 to 29. And thank you all who are directly and indirectly involved in this GIAN course for successfully conducted this 10 days GIAN course. Jai Hind, and I wish you all the success, and I wish you a happy new year to all of you. Thank you.
So I have some announcements to make. First and foremost, what we have given you in the registration kit, that was the idea that the kit which you have received is all made from the recycled things. That is the first. And the pens which you got, that is also a biodegradable pen, and that pen can be now converted into very beautiful flowers and everything. With that concept actually arised when we are discussing this sustainable blue circular bioeconomy. Professor Tiwari has suggested to go for this kind of thing, and I request each one of you to please go, and once you are finished with the pen, please sew it, take the photograph and tag us. It will be giving boost to not only us, but a sustainable future which we are planning. We are not only to talk about the sustainability, but we should be having an action towards the sustainability. So I will appreciate each one of you to go back and take the photograph with that. With that, I will invite Mishra sir kindly. I just forgot one of my research scholar, Professor Dr. Venkat. Please come here. Give him. He is actually scientist in Citrus Research Institute in Nagpur. He is doing QIP, and within 2.5 years, now I think he is going to finish. So with job, he is doing the PhD. So tremendous effort by Venkat ji. Also, I would like to name that I am committing that Ashwini ji, Umesh Pati ji and his team, we are here and to thank you guys. Because of you, Umesh Pati ji was actually going on holidays from 20 to 29, but because of request from us, he just postponed his all the commitments and he stayed here. I want to thank Umesh Pati ji, and I am committing that I will be giving something very good to all of you. So with this, I am just closing this session, and I hope that this is not the end. This is just the beginning. Some of you might come here for masters, might come for PhD. As we are in talks with some of you, we will be happy to host you as summer internship, or we are happy to host you as master students or PhD students. So do write to us. Once this relationship starts, we all the courses, we never forget, we never drop our WhatsApp group. Whatever you have, we will be posting our things, you will be posting your things, so that the mutual knowledge sharing will be going on. So I thank all of you, and tomorrow there is very good session is there. We will be having some question answer sessions and the feedback session in written, so that will be there. We will be again meeting tomorrow. So thank you so much for time being, but tomorrow again we will be meeting for a short session that will be just defining that how we are going to move forward, like a collaborative effort with your guides or with your university. We will be definitely talking about that also. With that, I thank each one of you for coming and attending. Thank you so much. And also I would like to call Brijesh sir to give to Miss Salom the certificate, who has done the anchoring now. She is our master students. Who all didn't came? Now come, we will have some samosa and chai to end this evening. Thank you so much.